Let us begin with the lecture for today. So, the topic we are going to look into in today's lecture, so it will be approximately three and a half hour long class. The first major part of the lecture today, we will be focusing on the topic of lighting, which is an important topic for your gate examination under the architecture part, that is part B1. And then we will also look into the topic of solid waste management towards the end, which is a minor topic, but it is also an important subject of the common part of the official syllabus of the gate examination. So first, let us focus on the subject of lighting. Later on, I'll be taking up solid waste management and we'll talk about the details of it. During the course of the class, if you have any doubts, you can put your queries into the chat and I'll address your questions. So first, let me give you an introduction to this subject which we're going to study, that is lighting and illumination. So as far as before I start with the concepts of this particular topic, let me give you a brief introduction to it, and then we'll look into the details of it. We'll also solve as many questions as possible from past gate and also some additional practice questions during the course of this lecture. So this particular topic, as per the official syllabus, like I said, it comes under part B1, that is architecture part. The weightage, if you see, so the questions from this topic have been asked under architecture. If you look into the official syllabus and then check the past gate papers, sometimes you will find deviations. Like for instance, HVAC or air conditioning systems is a topic mentioned in the architecture part, but there was a question, 2 marks question on it in the common part in the year probably 2022. Similarly, that's not just one instance. There have been many such instances where topics from architecture part or planning part have been asked into the common part as well. Similarly, a topic of common part has been asked into architecture planning part as well. So the boundaries are not very rigid in the gate examination, even though you have a defined syllabus. As far as this subject of lighting is considered, deviations have not been seen in the past years after change in the pattern from 2022. So for the last 3 years, questions of lighting have been asked only in the architecture part. Uh, just a second. Just give me a moment. Is the audio better now? Are you getting the audio? Okay, it's better now. Okay. So let us continue with the lecture. If you're having any query, you can put your queries into the chat. So I was telling you that this particular subject, lighting, question have been asked in the architecture part as well itself. We will. It's obviously not possible to go into the detailed concepts and study everything up, say in absolute detail, but we'll focus on the important concepts, solve the questions with a special emphasis on the numerical part. That's how we'll be addressing this subject in the upcoming 2.5 hours or so. The weightage for the past few years, in the year 2024, the weightage of it has been 2 marks. There was a theoretical question. So even though it was a 2 mark question, it was not completely based on the concept of, okay, it was not completely based on the, just give me a minute, please. Is the audio better now? Can you please give me a confirmation? Is it clear? Am I audible? Okay, so let us continue with this. Uh, Fine. Thank you for the confirmation. So I was telling you in the year 2024, there was a 2 marks theoretical question. However, that was not completely based on the topic of lighting. Part of it was based on the lighting. Basically, the measurement units based question was asked. In the year 2023, also there was a 2 marks theoretical question. In the year 2022, also there was a 2 marks theoretical question. In the year 2021, also there was a 2 marks theoretical question. So last 4 years from the subject of lighting, There has been there was a numerical in the year 2022 actually, 2021 actually. So there have been numerical or theoretical questions, 2 marks each every year for the last 4 years. So you can expect, I'm not saying that it will always be 2 marks of weightage, but on an average, you can say there will be a 2 marks of question from the subject of lighting. In the year 2020, there was no question from the subject of lighting. So that can also be a case. So there's no standard weightage in the GATE examination for any subject. In the year 2020, there was no question absolutely from this topic. So the weightage can be anywhere between 0 to 4 marks. There have been instances where 4 marks of question has also been asked on lighting itself. So on an average, it is 2 marks of weightage. So let us look into the details of this subject of lighting with that. So that's a brief introduction. What are we going to study? First, we will be looking into some important definitions related to the topic of lighting and illumination. There are some basic photometric properties. We'll look into those definitions. There have been a lot of questions in the examination on the measurement units. So remember, in the course of the lecture, whatever concepts we are learning, have a special emphasis on understanding the measurement units of all the terms. That's going to be important for your examination. And then we will solve numerical. So first theoretical concepts, then we'll solve some numericals, and then we might discuss some additional concepts too. So whatever content can be done in the upcoming 2.5 hours in the best possible manner, we'll be doing that for this subject of lighting. So let us first begin by looking into some basic photometric properties. So what exactly are photometric properties? Photo is basically light, metric is measurement. Photometric properties are those terms Ayush, like I said, it would be in brief. You can say we will, so in the detailed course, we will study in much detail. We will be doing all the concepts, all the important concepts, but not to that level of detail, which we generally do in the full length class. So photometric properties, I was telling you what exactly are photometric properties. These are those terms which are related to the measurement of light. Photo is basically light, metric is measurement, photometric properties are those properties which will help us measure the quantity of light basically. So let us look into some basic terms under the photometric properties, starting with the first one. So of the photometric properties from GATE point of view, there are three major photometric properties which are the most important ones in terms of numericals, also in terms of measurement units. So that's what we'll be first targeting to cover under the subject of lighting and photometric properties. Point number one is luminous flux. In the lecture, we'll be denoting it by F during the course of this lecture. So that's the first term. Maintain a proper running notes of the concepts you are studying so that you can write down the definitions and all, so that you can revise it later on. That's going to be important. Without revision, it is very difficult to retain new concepts and a lot of terms and definitions. So firstly, luminous flux. This is a measure of light energy. For example, if I ask you, there's a light over here, how much light is coming out of it? Now, light is a form of energy. Now, how do you measure energy? Generally, any form of, be it light energy, heat energy, sound energy, any form of energy, that's measured in joules. And the rate of flow of energy, which is called as power, that is measured in joules per second. How many joules of energy is coming out per unit time? That's called as power, that you measure in joule per second, which is nothing but watt. Now, these terms are not any specific and are not used for any particular type of energy, but these are terms. Joules and watts are measurement units which you can use for any form of energy, be it light, heat, sound, or any other form of energy too, for that matter. But luminous flux particularly is a term related to the rate of flow of light energy particularly. So that's the reason we add this word luminous. So flux generally is a term associated with rate of flow. So you also have heat flux. Rate of flow of heat can be called as heat flux, is basically a term related to that rate of flow of energy. So luminous flux particularly relates to the quantity of light energy emitted per unit time. So it is something similar to the flow of energy in joules per second. Sure. If you're not able to understand something, feel free to put into the chat. So I was telling you the luminous flux, that is rate of flow of light energy. Write down the definition into your notes. It is the quantity of light energy. It is the quantity of light energy. Luminous flux is the quantity of light energy emitted per unit time. You can write emitted or received actually per unit time. That's what luminous flux is. So I was telling you, if I ask you what is the quantity of light coming out from this light from a light source, the answer would be in terms of luminous flux. Basically, it tells you how much light energy is emitted or is received onto a surface. So it can be both ways. If I ask you how much light is coming out from this source, the answer will be in terms of luminous flux. If I ask you how much light energy is coming onto this table over here, if say there's a table and I've asked you how much light is coming onto this table, that you also measure in terms of luminous. So luminous flux in simple terms is a measurement of light energy, as simple as that. Measurement unit for it you have to remember, that is lumen. The SI measurement unit for luminous flux, it is lumen. So that's point number one. Light, quantity of light energy, measurement of quantity of light energy is called as emitted per unit time. That's called as flux. It is measured in lumen. Now, one thing to understand is when I say rate of flow of energy in general, not particularly one type of energy, that is measured in joule per second. That is watts. But here I'm telling you that light energy that is measured in lumen particularly, you cannot use lumen for other forms of energy. Now, how to convert lumen to watt? There is so these are basically related terms. Lumen is a measurement of light energy emitted per unit time per second. Similarly, rate of flow of energy in general is measured in watts. So to convert lumen to watt, there is a conversion factor which is steady moving further. It's called as luminous efficacy. So this depends on actually, so there's no standard conversion like X lumens will be so and so watts. You cannot have such straightforward convention, say the conversion from lumen to watts. Depends on the type of light source actually. We'll study about that in the upcoming concept. So first thing is measurement of light energy is called as measurement of flow of light energy is called as luminous flux and is measured in lumen. That's point number one. Moving on to point number two now. I'll give you a quick recall once we're done with the three definitions, but first we saw the definition and the measurement unit. Similarly, second term is luminous intensity. Denoted by I. So I'll give you the definition first and then we'll have a discussion on it. Write down the definition. Luminous intensity of a light source. Luminous intensity of a light source. Luminous intensity of a light source is the flux emitted by it. Is the flux emitted by it per unit solid angle. Luminous intensity of a light source is the flux emitted by it per unit solid angle. So it is basically the quantity of flux. Flux is nothing but light energy. How much light energy is emitted per unit solid angle. That's the definition for luminous intensity. Write down the mathematical equation based on this definition. Luminous intensity I is equal to the luminous flux upon solid angle, F upon omega. In this case, I is luminous intensity, F is luminous flux like we already studied and discussed. Omega over here is solid angle. Let me very quickly tell you what is solid angle so that you understand this definition in complete, in full, in its complete meaning. So firstly, what exactly is solid angle? In simple terms, solid angle is a three-dimensional angle. So for example, in two-dimensional geometry, if I ask you, if say this is a line and it is rotating by a particular, say degree of rotation. If I ask you how much is this degree of rotation, that is measured as a normal angle between two lines. Similarly, in a three-dimensional manner, for example, how can you visualize a solid angle? Solid. I'll go back to the definition, but first let us very briefly understand the concept of what is solid angle. So to visualize solid angle in a physical manner, you can think of it in terms of the three-dimensional angle at the tip of a cone. If you have looked into a cone, a hollow cone, let us say, if you look inside a hollow cone, you will have a three-dimensional angle at its tip. Not only cone, even pyramid for that matter. If you look into a hollow pyramid, look into the inside of it, you will have a solid angle over here. Right? So in a triangle, you'll have a 2D angle, that's a 2D shape. In a three-dimensional form, like a cone or a pyramid, you can look at solid angles. So these solid angle in simple terms is like a three-dimensional angle. And just like how normal angle is measured in degrees, or in radians. You measure degree angle in degrees or radians. Similarly, solid angle is measured in units of steradians, which in short can be written as SR, steradians. I'm not going into the detailed geometry of how we measure solid angle in steradians. That's not something which is important from gate point of view. But if you are interested, you can further study about solid angle and how it is measured. But in simple terms, you can remember two things. Number one, solid angle is a three-dimensional angle. You can visualize it at tip of 3D forms like cone or pyramid, for instance. How do you measure it, or what's the measurement unit? It is steradians. Just these two things, that is sufficient. Further, if you want, you can look into it, but not necessary from gate point of view. Coming back with that understanding. So solid angle is measured in steradians. So now coming back to the definition, let us try to understand it again. It is so first thing, it is measured for a light source, luminous intensity of a light source, I said. So you measure it for a bulb or a light emitting, say some object which emits light. So for a light source, it is the quantity of flux emitted per unit solid angle. Unit solid, can anyone tell me what is the meaning of unit solid angle? How many solid angles are we talking? What is the meaning of unit? How many steradians are we talking about? Unit का मतलब one, right? So per units for one steradian solid angle, how much flux is emitted? Flux emitted per steradian. So for example, if you have a bulb, and let us say this is emitting flux, light energy emitted, it is emitting in all the directions, let us say, in a given particular solid angle. So solid angle is measured in steradians, that is one steradian. From this one steradian solid angle part, from this portion, how much of light energy or how much of flux is received or is coming out? That is called as intensity. So intensity is nothing but the quantity of flow of light energy, but which is coming out of one steradian solid angle. Now, if imagine there is a light bulb which is giving you a lot of flux from one steradian solid angle, it means it is of higher intensity. If there's a bulb which is giving you less quantity of light energy from one steradian solid angle, it means it is of less intensity. So in simple terms, intensity, it's like the brightness of a light source, how much energy it is emitting. That's basically intensity. So from the name itself, you understand intensity is how intense the rate of flow of energy is. So it is flux emitted per unit solid angle. From this formula over here, can anyone tell me what is the measurement unit for the numerator? Flux is measured in just a while, just 5 minutes ago we discussed. It's measured in lumen, absolutely correct. So why am I having a special emphasis on the measurement units? Because theoretical questions multiple times have been asked in the gate examination, just on the measurement units also. What is the measurement unit for the denominator solid angle? Absolutely correct, steradian. So the measurement unit for luminous intensity will become lumen per steradian. That's the measurement unit. And lumen per steradian in SI units, lumen per steradian is also called as candela. So that's the measurement unit for luminous intensity. You can remember this is candela. Just like joule per second is called as watt. Similarly, lumen per steradian is called as candela. So I'm writing over here the measurement unit again. We had a discussion on it. The definition, then the measurement unit. Luminous intensity is measured in lumen per steradian. And this lumen per steradian is referred to as candela, which is denoted by CD. So that's something you can remember. Before we move on to the third and most important definition, let us also look into one additional concept which can be asked sometimes in the examination too. That is with respect to the solid angle for a point source. Let us try to understand if there's a point source for a point source which emits light in all directions. Let us try to understand how much will the solid. So what do you understand from the term solid angle? It tells you about the three-dimensional angle in terms of the nature of propagation. So for example, let us say I design a bulb or a light source which is emitting light only in this particular direction like this. Let us say light is emitted only from this portion. So this is a solid angle associated with this particular source compared to point source which is emitting light in all the directions. Can you tell me case 1, case 2? This is a point source. This is a source which is like a spotlight, which is generating light only in this particular, from only this particular portion. Comparing these two, can you tell me in which source do you think there is a higher solid angle for the propagation? for the shape of propagation, where do you have a higher solid angle? Here it is a very small solid angle, light is coming only from this band, but here light is emitted in all the directions, just like 360 degrees in a normal 2D angle. Here it is three-dimensional, so the propagation will be almost in the form of spherical propagation in all the directions, right? So let us try to understand how much is that solid angle for total propagation. That has been asked once in the year 2013 GATE examination, long ago, but questions can always be asked after even a long span of 10-15 years too sometimes. So let us try to understand this concept of what is the total solid angle for a point source which emits light in all the directions. You can also write it as total solid angle for spherical propagation. Why am I calling it a spherical propagation? Because light, if it emits in all the directions three-dimensionally, the propagation will be in the form of a spherical propagation. Total solid angle for spherical propagation. That's what we are looking into. For a point source which emits light in all the directions, the solid angle will be the total solid angle, which is in the case of a spherical propagation. So solid angle, 3D angle is measured as the ratio between the area subtended by it. So let me just give you a bit of background to understand better, rather than directly putting it out to you, the formula. Let me give you a bit of background so that you can remember it in a better manner. If you know how angle is measured in radians, let us say there are, let us say this is a circle, this is a radius, this also is radius. If I ask you what is this angle theta in radians, not in degrees, if I ask you what is this angle theta in radians, it is measured as the ratio between the length of the arc subtended by the angle. This angle will subtend a particular length of the arc. Let us say this length of the arc is L. Length of the arc subtended by that angle divided by the radius. Theta in radians is defined as the ratio between length of the arc subtended. I'm talking about 2D angle here, not related to lighting, but just to help you understand in a better manner, I'm talking about the 2D angle here. 2D angle in radians is measured as the ratio between the length of the arc subtended by that angle divided by the radius. This ratio will give you the angle in radians. So based on this concept, can anyone tell me, if I ask you how much is the total angle at the center of a circle in degrees, can anyone tell me how many degrees is the total angle at the center of a circle? For sure, that will be 360 degrees. Now let us try to find out that 360 degrees, how much will it be in radians? For total angle, the length of the arc subtended by it will be the total length. Can anyone tell me what is the formula for this total length of the arc subtended by full 360 degrees? That will be the total circumference of the circle. Circumference of the circle is 2 pi r. So this basically theta will be length of the arc subtended by the total angle, that is 2 pi r divided by r. So this comes out to be 2 pi radians. Right? So this is how you measure radians in 2D angle. Length of the arc subtended by an angle divided by the radius. Similar concept is used in three-dimensional angle also. This is not necessary. You need not write this into your notes. Not related to lighting. What we are interested in lighting is spherical propagation, three-dimensional angle, 3D angle, that is solid angle. So in solid angle also the concept is similar. As if say this is a spherical surface, a solid angle is measured as the, let us say there's an area on the spherical solid. Let us say this is an area A, right? If I join the extreme points of this area to the center, let us say I'm considering something uh, on the spherical surface. If I take a particular area A, I join the extremes to it to the center, I'll get a solid angle at the center over here. Can anyone tell me the distance from these points, this point, this point, and this point to the center? Are these distances same or different? These points to the center, if I join, all those will be same because every point on the sphere will be at same distance from the center, and that will be r, right? So this distance was also r. So basically this solid angle omega in three-dimensional angle, it is measured as the ratio between area subtended by that solid angle divided by the square of the radius. So it is L by R in case of 2D angle. In 3D angle, it is measured as area subtended by the solid angle. Now I might have drawn it something spherical, almost close to a square shaped. It can be any random organic shape also. Any shape will subtend a particular solid angle at the center. So that solid angle is measured as the area subtended by it on the spherical surface divided by square of the radius. This ratio will give you the solid angle in steradians. This is how steradians are actually measured. So based on this concept, can you try to find out what is the total solid angle for the spherical propagation? So in case of total solid angle for spherical propagation, you need to take the total area for this total solid angle. You need to take the total spherical area. Can anyone tell me what is the formula for the total surface area of a sphere? What is the total surface area for a spherical surface? 4 pi r square, that's the formula in geometry, and divide by r square. For spherical propagation, this is how much you will get. So what is the total solid angle for spherical propagation coming out to be? Omega will come out to be 4 pi steradians. That is equal to. So just like how angle 2D angle at the center of a circle is 2 pi radians, which is 360 degrees. Similarly, for a spherical surface, the total solid angle at the center will be 4 pi steradians. This is something you have to remember. And for which type of source will you have 4 pi steradian solid angle? For a spherical propagation, which is seen for a point source which emits light in all the directions equally. So that's basically the total solid angle for spherical propagation. If you want for numerical, so if you get a question, what is the total solid angle associated with a point source of light? In such cases, if it is an NAT type question, obviously you cannot type pi into the input box. You will need to take the value of pi, which is 3.14. Can anyone tell me, taking 3.14, what is the total solid angle coming out to be? 12 point something? 12 point, Shraddha says 12.56. I think that's correct. 12.56 steradian. That's the total solid angle for spherical propagation. Remember one important point here, because I'm talking about NAT questions in the gate examination. You all know by this point of time that there are three types of questions, that is NAT questions, MCQ and MSQ questions, multiple select questions. NAT questions have no negative marking, and there will be an input box where you can type in values from 0, 1, 2, 3, 4, so on till 9. There will be a decimal point. You will have a negative sign also, because sometimes answer can be negative values, like -20 was an answer for one question in the past exam. So you need to type the negative sign also. If it is a positive answer, you need not type plus. Very rarely, but you have negative answers too sometimes. So you will just have an input box. So you need to type in the decimal point and type the values up to 2 decimal places generally. They'll specify in the question, accordingly you need to answer. And there's no negative marking. That's the best thing of NAT questions. So it is scoring in that manner. So that's about this concept of solid angle and the concept of luminous intensity. A very quick summary. We have looked into 2 points till now. Point number 1, luminous flux. We saw the definition, and I told you that it is measured in lumens. Point number 2, we looked into luminous intensity, which I told you is defined as flux emitted per unit solid angle, which is measured in lumen per steradian, which is also called as candela. These are the two concepts we looked into till now. Hope it is clear to you all. If anyone has any question in understanding any concept, you can put it into the chat and I'll address it. Is it clear till here? Please give me a confirmation. Okay, let's now move on to the second concept. Third concept under the basic photometric properties, that is illuminance, which sometimes can also be termed as illumination, which is generally denoted by E, because I use it already for intensity. So we'll be using it with E, denoting it by E. Illuminance is same as illumination. Do not get confused. Illumination or illuminance is different from luminance. There's another term called as luminance. That is not same. Illuminance is different, luminance is different. Luminance will come to it towards the end. Illuminance is what we are studying. Both are very much different and the measurement units are also different. So you should not get confused between illuminance and luminance. We are talking about illuminance here, that is E. First write down the definition, then we'll have a discussion on it. It's very simple concept. If you understand the first and second concept, which we already studied. So illuminance, write down the definition for it. Illuminance of a surface. Illuminance of the surface is the flux received by it. When I say flux, we're talking about luminous flux over here. We'll come to it, KZ, when we solve some numericals. Illuminance of a surface is the flux received by it. Illuminance of a surface is the flux received by it per unit surface area. In brackets, you can write A. After flux, you can write F over here in the brackets. Illuminance of a surface is the flux received by it per unit surface area A. So that's the definition for what is illuminance. You can write down the formula over here. Illuminance E is flux received by it per unit area, F upon A. That's what illuminance is. Illuminance of a surface is the flux received by it per unit area. For example, let us say there's a table over here which is receiving some light energy from some light source on top of it. If I ask you, what is the illuminance of this surface? That is nothing but the flux received by it per unit surface area. Per every unit area, for 1 square meter area, how much light energy is received onto the surface. So if you compare it with the previous definition, luminous intensity was how much light energy, how much flux is emitted by a light source from one steradian solid angle. That's the intensity. That's measured for a light emitting source. Here, illumination is measured for a surface which is receiving light. It is not for a source. I cannot ask you what is the illuminance of this light source. That will be an illogical question because light source is emitting light. It's not something which is receiving light. It's not getting illuminated. Illuminance is measured for an illuminated surface like a floor level, or let us say in an exhibition you have a painting, so that will be an illuminated surface. Illuminance is measured for an illuminated surface. It is the flux received by a object or by a surface per unit surface area, that is F upon A. So based on this definition, if we look into the formula for it, so the measurement unit for it, flux is measured in lumen, area is measured in square meter. So the measurement unit for illuminance will become lumen per square meter plus received per unit area is lumen per square meter, which in illumination is termed as lux. I'm sure you might all have studied about or heard about this term lux. Let us say the requirement of lighting in this room is 100 lux. So that basically lux talks about the flux received per unit area. How much light energy is received per unit area, that's called as the lux level. And from architecture point of view, and lighting design point of view, this is the most important and most frequently used term because this is what defines the visual comfort of a space. If you are not maintaining the required lux level, for example, I want to use this room as a classroom. Let us say students are sitting over here and writing into their notes. When will they able to write down clearly and look at it clearly? When there is sufficient lux level. If the light energy per unit area, if it is less, it will not be clear or legible. So for every type of space, there are recommended values of lux. Generally for classrooms, it should be around say 200 to 200, 300 or 400, something of that range. So NBC gives guidelines. There are 3 or 4 pages of standards given for different types of spaces. What is the recommended lux level? Generally, it is given in different cases like the minimum and the maximum limit. So there's a range for it. However, you need not remember all those values. If you have time, you can briefly look into it once. What is the recommended range generally for spaces? That's what you can have a look at. But by hearting 3 or 4 pages of tables, that I don't think is something which is important or which is even practically feasible for you. Because if you start doing it in every topic, there will be such a huge ocean of information which you cannot retain in the examination. So you have to prepare wisely. You have to know what to by heart and what not to by heart. That's also important for your examination. So that's with respect to the definition of illuminance. So we looked into 3 basic terms, 3 basic formulae, 3 basic measurement unit. Now taking it further from here, the next point. Now flux per unit area, like let us take up an example for instance. Let us take up an example. This is not a past gate question. We're just taking up a very simple example. Write down a question. Uh, a surface of area 10 square meter is illuminated a surface of area 10 square meter is illuminated by 2 lamps with 1000 lumen flux output each. A surface of area 10 square meter is illuminated by 2 lamps of 1000 lumen flux output each. Illumination of the surface. will be dash lux. Can you calculate and tell me? This is not a gate question. This is just a example for you to understand the basics. How much will be the flux received per unit area? So the total flux in this question, total flux received on the surface, that is, there are two lamps and every lamp is giving me 1000 lumen. So the total flux is 2000 lumen. And this 2000 lumen is received on how much surface area? The total surface area which is receiving this lumen, that is given as 10 square meter. So based on this simple concept of illuminance, that is flux received per unit area, flux received is 2000 lumen and that is received on an area of 10 square meter. So this will be 200 lumen per square meter and lumen per square meter is called as lux. There was a gate question once on this point also. Like in match the following, you had to match lux with lumen per square meter. So you have to know lumen per square meter is lux. Similarly, what is candela? It is lumen per steradian. So understanding these relations also is important from exam point of view. They can ask you such questions too. So in this case, it is 200 lux. So flux received per unit area. Now here, what are we doing? We are considering an average illumination on the surface. Let us say there's an area of 10 square meter. There are two lights. So in practical terms, probably the light will not evenly distribute 100%. For example, so what I mean to say over here is, let us say there's a surface area of 10 square meter. There are two lamps which are giving light onto this surface area. It might so the light received at the corners might be a bit less. Light received just below it might be higher. So the distribution might not be 100% uniform on a surface, but we are finding out it to be 200 lumen per square meter on an average. So illumination is flux per unit area. If you use this formula, the illuminance you get, that will be the illuminance on the surface on an average. What is the illuminance of the overall surface on an average? That's the average illuminance of a surface, flux per unit area. However, when you want to find out the illuminance at a particular point, for that we generally use another formula. So that's the next point we are looking into, which is also referred to as inverse square law of illuminance. So take down the next point. This is not another term altogether, but write it as point number 4. That is inverse square law of illuminance. I'm not going into the basics of the derivation of it and the basis of how we get that formula. We're not going into that level of detail over here, but we will focus on the conceptual part of it. Let us try to understand how do we find out the illuminance at a particular point using inverse square law of illuminance. We'll understand it and solve the questions in detail. The derivation part, I'm skipping through it over here. I'll not go through the basic derivation concepts. So inverse square law of illuminance is nothing but it is used when you want to find out the illuminance at a particular point. In terms of the intensity of a light, if you know that there's a light source of a particular intensity, then you use this inverse square law. So let us try to look into how you find out illuminance using inverse square law. So illuminance using it, you can write down the formula for it right away and then I'll explain you how the inputs are taken in it. We'll practice some questions also. So generally in our full length course, we look into the derivation, how that formula comes into usage and so on. I'm not going into those in depth and understanding at this point of time because you need to given the based on the amount of time you have for your preparation, accordingly you'll need to strategize things. So let me not go into those intricacies. So illuminance in inverse square law is given by intensity of the light source I upon r square into cos theta. So that's the formula. Let me tell you about each of the elements in this formula and then we will try to solve some questions with the application of it. Why is this? Firstly, why is it called as inverse square law? Because you can see in this formula, illuminance is inversely proportional to the square of the square of the radius in the denominator. So E is inversely proportional to R square. That's how it is called as inverse square law in illuminance, basically. Uh, okay, so E is equal to I upon R square into cos theta. Let us try to understand each of the terms. E is illuminance, like I said. This is illuminance at a given point. There are three inputs required. So whenever you have questions in the examination where you'll need to find out illuminance at a particular point, this is not the average illuminance of a surface. This is illuminance at a point. Or whenever you have questions related to the application of inverse square law, sometimes in the exam they'll clearly state calculate the illuminance using inverse square law. Like there was a 2 marks question in 2021. They have clearly stated in the question, calculated using inverse square law. Based on given information, you need to apply the concept. The illuminance at a given point will be I upon r square into cos theta. So to solve this, there are three inputs required: I, r, and cos theta. What each of these terms are? Firstly, what is I? You can write down. I is the luminous intensity of the light source. I is luminous intensity of the light source. Now, we'll come to the details of if there are multiple sources, what do we do? We'll come to it. But for now, remember, I is luminous intensity of the light source. R here is distance from the source to the point of illumination. R is distance from the source to the point of illumination. From the source to the point, that distance is R. Theta here is angle of incidence. And you need to know what is angle of incidence. This is actually one of the most important thing where many of the students tend to do a mistake. Angle of incidence in illumination, it is defined as the angle between the incident light ray and the normal drawn at the point of incidence. Normal is in perpendicular. So I'll draw a diagram and tell you what is angle of incidence. For example, let us draw a diagram to understand all these 3 points actually. Let us say this is a table or something. Let us say this is a surface where this is a point of illuminance, which is receiving light from a source which is located something over here. Let us say this is a bulb which is emitting light and and illuminating this particular point. And if you want to know what is the illuminance at this point, it will be intensity of this light source I divided by square of the distance I upon r square. What is r? It is distance from the source to the point of illuminance. This distance, that is r. So it is distance from the light to the point of incidence, to the point of illumination. I upon r square into cos theta. Now what is theta? Cos is cosine. Cosine of angle theta. What is theta? It is angle of incidence. That is angle between the incident light ray and the normal, that is perpendicular drawn at the point of incidence. This is the point of incidence. If I draw a normal at the point of incidence, that blue line, the blue dotted line is a perpendicular line drawn at the point of incidence. It's called as normal at the point of incidence. Angle between the incident light ray and the normal drawn at the point of incidence, this angle is called as theta. So if I say angle of incidence, generally in the examination, sometimes they will explain it to you in detail. Angle between the incident light ray and the normal is 30 degrees. That's how they'll say. Sometimes they'll just tell angle of incidence is 30 degrees. And you need to draw the diagram in order to do the calculations. We'll take up some questions you will understand. But angle of incidence is always, this is what you'll take. Angle of incidence is angle between the incident light ray and the normal drawn at the point of incidence. So this is the point, the perpendicular. So this is a table. The normal is something which comes out of that surface, perpendicular line drawn at the point of incidence. So this is about this formula. Angle of incidence, cos of the angle of incidence is to be multiplied with I upon r square. It is called as inverse square law. This is used to find out illuminance at a particular point where it is receiving light from a particular source. Now, there will be two things in addition to this based on this. Before I move any further, please give me a confirmation. Are you all able to understand the use of inverse square law and the inputs required in it and the formula for it? This is the formula you have to remember, and this diagram and the input values. Clear till here? Yeah. So two things in addition to, in extension to this, you need to remember two basic important concepts. First one is uh, if there are multiple sources, then what? Let us take up a case. For instance, there was a question of this level in the gate examination. We'll solve that question just in a while. But let us say there is a surface, and let us say this is a point of illuminance. Let us say this is P, and then let us say there are two sources. There's a bulb over here, and there's a bulb over here also. This also is giving light, which is at a distance something, let us say R1 or let us say R. This is a second source also at same distance R. This is having an intensity I. This also is having an intensity I. Both are giving or illuminating this particular point. So what will be the illuminance at this point? In this case, there are multiple sources. How do you find out illuminance using this E is equal to I upon R square into cos theta? Which I will you take? You will so how do you calculate in this case? it will be calculated individually for both the cases. Like first you calculate it for this first source. Let us say this is as source 1, source 2. For both the sources, you will apply this formula and then add it. So the total illuminance will be illuminance due to source 1 plus illuminance due to source 2. So it is additive. No, imagine it in practical terms. Let us say there's only one light. It will receive some illuminance E1 or ES1, that is illuminance due to source 1. If I'm adding one more light of same intensity, the illuminance will get doubled. The illumination level will be increased. It will become double. Why? Because I'm getting one more source. It will add up. So illuminance is additive in nature. If there are multiple sources, illuminance gets adds up. You can apply inverse square law for each case and add them individually to get the total illuminance at a given point. That's one additional point you have to remember. If there are multiple sources, you add the illuminance contribution of every source to get the total illuminance at a given point. That's one point you have to remember in addition to the inverse square law. Second concept is, so first I'll just write down over here within this inverse square law, there are two cases we are discussing. Case number one, for multiple sources, you can draw a diagram itself instead of writing everything in terms of statements. Because we're not left with a lot of time now. You will just revise your quick note, revision notes later on. So looking at these diagrams, you will understand and remember the concept very easily. So let us say this is distance R1, this is distance R2. Let us say illuminance of this is, intensity of source 1 is I1, intensity of the second source is I2. And if say this is the point P, total illuminance at point B will be illuminance due to source 1 plus illuminance due to source 2. So add both of it, to get the total illuminance, right, at point P. Illuminance of source 1 is nothing but I1 upon R1 square into cos theta or cos theta 1. Plus for the second source also you'll apply I2 upon R2 square into cos theta 2. What is theta 1 and theta 2? Angle of incidence of the first line. Angle of incidence is always angle between the incident light ray and the normal drawn at the point. This is theta 1 and this is theta 2 in this diagram. You can take down this diagram, it will be easy and you can easily remember. However, in the examination till now, complex questions of this model with two different sources of different intensities and different angles, that has never been asked. Questions have been asked when there are multiple sources but at same distance, same angle, same intensity. Such questions have been asked. So it will just become double. If there are two sources at same distance, same intensity with same angle, intensity will just become double of the intensity illuminance of each light. Basically we'll solve question in a while. Second point, other than this, you can remember is a special case where the light is perpendicularly above the point of incidence when the source is perpendicularly above the point of illuminance. When the source is perpendicularly above the point of incidence, or when the source is perpendicularly above the point of illuminance, in that case, how do we calculate the illumination at that point? Let us look into it. Let me draw a diagram. Let us say this is a surface and this is a point P and there's a light perpendicularly above it. So light is just perpendicularly coming onto this particular point P. This is a light source. Let us say the intensity of it is I. This distance is R. Let us try to understand what will be E. Apply that same formula, is equal to I upon R square into cos theta. Now here, can you even tell me by looking into this diagram, what is the angle theta for this incident? This is the incident light ray. What is angle theta? What is the angle of incidence? Is it 90 degrees or 0 degrees? That blue line is the surface normal. What is the angle of incidence in this case? Angle of incidence is always defined as the angle between the incident light ray and the normal drawn at the point of incidence. That is perpendicular drawn at the point of incidence. So both are coinciding. Basically, the angle is zero between the angle between the incident light ray and the surface normal. That is 0 degrees. So in this case, for perpendicular incidence, remember theta will be 0 degrees. So if you substitute that value of 0 over here, you will get E is equal to I upon R square into cos 0. Can you even tell me what is cos of 0 degrees? Cosine of 0 degrees, how much is it? Cos 0 is 1. So if this becomes, so this is basically 1. Cos 0 is 1. So you will get E is equal to, so for when the source is perpendicularly above the point of illuminance, in this case, illuminance will be E is equal to I upon R square. As simple as that. However, remember, so this is something you can remember, but remember this equation, this formula, even the inverse square law formula, it is not consistent with measurement units directly because see, I is measured in candela, candela per square meter is not lux. So E is measured in lux, which is lumen per square meter. So it might not be consistent with measurement units, this particular formula. There are reasons for it. We're not going into the derivation point. But remember, this is a equation which you can remember for illuminance at a particular point. So that's about the illuminance. Let us now solve some past gate questions to understand. Then there's one more topic, one more area of numericals which is important, which has been asked in the gate examination, which is calculating the number of lamps. We'll move to that. But before that, first let us practice questions on concepts we have studied till this point. Uh, Srishti, it is not surface normal for the point of illuminance, not the source. Irrespective of where the source is, I will draw a normal at the point of incidence, where the light is received finally. So if this is an illuminated surface, light is over here. I'll not draw normal for the light. It is normal to the surface where the point is, the point of illuminance is. So that's the surface normal. Angle between that and the incident light ray, that is called an angle of incidence. Is that clear? Okay. For elements of surface, we will take E is equal to I upon R square for elements at a particular point, inverse square law. Absolutely wrong. That's not correct. Not sure what your name is, KZ. But E is equal to I upon R square is used when the light is perpendicularly above, in this case. E is equal to F upon A is used for a surface on an average. At a particular point, you will use, because to find out distance R, you need to know the point where the illuminance is happening, right? So that's how you can remember. E is equal to I upon R square and E equal to I upon R square to cos theta. All these inverse square laws generally applied for a particular point. Is that clear, KZ? Let us take up some questions now. Ha, correct. You're right. Which case are you talking about, Soumya? Acha, are you talking about the surface normal of the surface of the light? Is that what you're talking about? So let me clear that. Soumya, if say this is this is basically a light source. Now the light, so you don't, if I just give you a surface, now you don't know along which surface that light source is. It might be installed on a horizontal ceiling, or it might be on inclined surface, or it might be on a wall. So you don't know. Based on the inclination of that surface, the angle, the normal will change, the orientation of it will change. So that's the reason you don't take that as the reference. Rather, you'll take the reference as always the point of illuminance on the surface. Is that clear, Soumya? Are you able to understand why we don't take the surface normal with respect to the light? Huh. So we can directly put I in place of F for E. Shubham, actually, no. There is conversion, like how you can convert E to. So there are two formulae. Let me very quickly write down. E is equal to F upon A is one formula, flux received per unit area. E is equal to I upon R square into cos theta is one formula. Can you replace I with F in any of these formula? No, because I and F are not always equal. They will be equal for a steradian of one solid angle, for a solid angle of one steradian. Why? Because the relation between I and F, intensity is given as flux received per unit solid angle. So this implies flux will be I into omega. When will I and F be equal? When omega is 1 steradian, then I and F can be interchangeably used in both the formulae. But if omega is not 1 steradian, if it is a point source which is having spherical propagation, then omega we saw already it will be 12.56 steradian. So based on the solid angle, this conversion will change. So you cannot always replace I with F, Shubham. So remember that point. Let's take up some past questions now. The first one we'll be solving is a gate question from the year 2012. Make a note of this question. I'll just give you a question on it. It's not a very lengthy question, so you can quickly write it down as well. So this is a 2 marks numerical from the year 2012 gate examination. This is the simpler one. We'll solve simple questions, one or two simple questions, then look into a bit difficult ones too. Write down this question. A painting is to be lighted at 250 lux. Write down the question. A painting is to be illuminated at 250 lakhs. I hope you all know where to access the past GATE question papers from. On the official website of the GATE examination, you can bulk download the question papers for the last 15-20 years or so. So whatever question papers, you will find the 2012 paper also on the official GATE website. You can always download the question papers for your practice. Painting is to be illuminated at 250 lux. That's the first statement given, full stop. If the light is incident normally on the painting, if the light is incident normally on the painting, if the light is incident normally on the painting from a distance of 6 meters, from a distance of 6 meters, then the intensity of light source required is dash candela. Then the intensity of light source required, then the intensity of light source required is dash candela. Take a minute and try to solve this question. It's a very straightforward, simple question actually. Many of you have an answer already. 9,000 candela. So what is the Aparna, those past papers even before 2007, those are not available on platforms on any public platform as such directly. So there's no other way. Like probably if you know someone who attempted those past papers, you should access, because on the official GATE website they only upload papers from 2007 till present. Uh, the illuminance of a surface E is given as 250 lux. The light source is incident normally on the painting from a distance r, that is given as 6 meters. Intensity I is being asked. So in this particular question, in this particular case, if I apply, so whenever you want to measure when the distance is, so which formula to apply? E is equal to F upon A is one formula. E is equal to I upon R square is one more formula. Which formula to use? It depends on the given information. Here, R and I, the relation between that is being asked. So you will apply inverse square law. There's no point of applying E is equal to F upon A in this question. So E is equal to inverse square law is equal to I upon R square into cos theta. So in this case, it is given that the light is incident normally. When light is incident normally, perpendicularly. When the light is incident normally, what will be the value of angle of incidence? Theta will be 0 degrees. Cos theta will be 1. So this basically will be 1 itself. So that you can remove it out. E is equal to I upon R square. That's what you can apply. So this implies E is equal to I upon R square. E is 250. That is equal to I upon R square is 6 square. That is 36. So this implies intensity is 250 into 36, which will give you 9,000 candela. So all of you, whoever have put your answer into the chat, that was the correct answer. E is equal to, applying equal to I upon R square, I get intensity as 9,000 candela. Straightforward question, was asked for 2 marks in the year 2012. So that's one of the simplest questions you can say. Let us look into a bit difficult one. So we'll see 3 levels of questions. It's a simple question, that is done. We'll look into a question which is of medium level, you can say, in terms of difficulty, and then we'll look into a difficult question from past GATE. 3 questions. The second question, this is also a past GATE question for 2 marks again from the year 2016 GATE examination. Make a note of this question. A lamp source of 3200 candela, a lamp source of 3200 candela, CD I'm writing in short, 3200 candela, is mounted on a wall at a height of, is mounted on a wall at a height of is mounted on a wall at a height of 2 meters from the work plane. 2 meters from the work plane. It subtends an angle of incidence of 60 degrees, full stop. It subtends an angle of incidence of 60 degrees. It subtends an angle of incidence of 60 degrees. It subtends an angle of incidence of 60 degrees with the center of the work plane. With the center of the work plane. The center of the work plane, full stop. The illuminance at the center of the work plane is dash lux. The illuminance at the center of the work plane is dash of the center of the work plane. Now this is not very straightforward like the past one. You will need to draw a diagram to understand and answer this question correctly. Take a minute, try to draw, do not answer such questions, including this. Never answer such questions without drawing a diagram. You for sure will do an error if you answer it without drawing a diagram for the given case. So wherever possible, you should always try to draw a diagram. You can visualize things in a better manner with that. So lamp source, first look into the given information and then draw a diagram for it. Lamp source of 3200 candle. Now, if you see in this question, a lamp source of 3200 candela, now then have not told what is this 3200. By looking into the measurement units, you should understand. Can anyone tell me, by looking into the measurement units, what is this 3200? Is it F or I? Because for a light source, you can measure or define F. You can also define I. But this is I. Based on the measurement unit, you can understand that the intensity is given. So from this itself, you know that you'll basically be applying, because you're having angle of incidence, you're having a distance, you're having intensity. You'll be applying inverse square law of Fisher here. Is mounted on a wall at a height of 2 meters from the work plane. The angle of incidence is given as 60 degrees. The illuminance at the center of the work plane is being asked. So you can first start by drawing a diagram for this. So this is a surface, and there's a wall also in this case. This is a work plane, let us say. Illuminance will be 100 lux. Okay, many of you have an answer already. So let us see. Let us say this is the work plane level. Generally, work plane is defined as a plane at almost 90 centimeters from the floor level. Generally, depends on the usage also. Work plane is basically that level which has to be illuminated by the lights in that particular room. So if say this is a work plane, and on the wall they are saying that there's a lamp of 3200 candela which is at a height of 2 meters from the work plane. So from the work plane at a height of 2 meters, there is a light over here on the wall. So this height is given as 2 meters. That's where the light is. The angle of incidence also is given. The intensity of this light source also is given I. That is given as 3200 candela. This height is given as 2 meter height on the wall. Then the angle of incidence is given as 60 degrees with the center of the work plane. Say this is the center of the work plane. The angle of incidence is the angle between this incident light ray and the surface normal drawn at this point of incidence. So this angle is angle of incidence, that is given as 60 degrees. That's also given. Next, they're asking us the illuminance at the center of the work plane at this point. You know how to calculate illuminance E? E is equal to, so in such, once you draw the diagram for the given information, you just need to know what concept are we applying. In this question, I'll be applying inverse square law. E is equal to I upon r square into cos theta. This is what I will apply. In order to give an answer to this question, three things I need. I need need r, I need theta. Of these 3 points, 2 things are directly given to you. I is directly given, just direct substitution. Theta is directly given to you, 60 degrees, direct substitution. All you need to work on in this question is to find out R. And what is R? Can I take R as directly 2 meters? Is R also directly given? Absolutely no. Why? Because R is distance. I told you already in the definition over here when we looked into inverse square law. R is distance from the source to the point of illuminance. From the source to the, it's not the vertical distance, it is this distance from the source to the point of illuminance. So same thing you apply over here. So that green line is basically R. So for that you'll need to use basic trigonometry and apply some sine, cos, tan probably. So let me draw out this right angle triangle, because that hypotenuse is basically R, right? This triangle I need to draw out because this is R. So if I draw out this right angle triangle, let me draw it over here again. So for this right angle triangle, this vertical height is 2 meter. This distance is R. This is 2 meter. This is 90 degrees. Can anyone tell me how much this angle will be at the base? If this angle of incidence is 60, what will this remaining angle be? The remaining angle has to be 30 degrees because total it is 90. This is a surface normal. This has to be 30 degrees. So this angle is 30 degrees. Alternatively, you can take this angle at the tip, that also will be 60. You can also take that. And so in this right angle triangle, to find out R, what can I apply? So basically for 30 degrees, this is the opposite side. What is the ratio between opposite side and hypotenuse for an angle called as sine, cos or tan? Absolutely correct. It is sine 30 degrees. So in this right angle triangle, sine of angle 30 will be ratio between the opposite side, length of the opposite side, that is 2 meter, divided by the length of the hypotenuse, that is r. And what is the value of sine 30? It is 1 by 2. You can remember. However, in the examination, you will have scientific calculator. If you don't remember the value, you can always use it. However, sine 30 is 1 by 2. I hope you all know that. So this implies r will basically be equal to, so this will be 1 by 2, so this becomes 2 into 2, that is 4 meter. You will get r as 4 meter in this case because r goes to this side, sine 30 will come to the denominator, sine 30 is 1 by 2, so that basically multiplies 2 into 2, you'll get 4. R I'm getting it as 4. So just one thing which was not directly given in the question, I have calculated. Now just substitute into the formula and get your answer. E is equal to, intensity of the source is 3200 upon square of the distance. R is 4, square of 4 into cos theta. Can anyone tell me what will I take theta here as, 60 or 30? Will I take 60 or the angle between the incident light ray and the normal, 60 or 30? Which one will I take? Angle of incidence is clearly stated also here. Angle of incidence is 60 degrees. So you will take cos of 60. Cos 60 also is 1 by 2. So you can simplify this. 3200 divided by 16 into 2. Why will I get 2 in the denominator? Because cos 60 is 1 by 2. So this basically will be 100 lux. That's the correct answer for this question. Hope this is clear. Can we take cos 60 is equal to 2 by r? Absolutely, yes, you can do that too. So if say this is 60 degrees, right? Cos 60 is 2 by r, you'll get the same answer, Tanmay, even if you do that. So it's either way. You can work out with 60 or 30 degrees because you know both the angles in this triangle. So that's about it. Let us now move on to the next. Okay. Which point are you confused on, Angel? You need to be specific. Did you understand that the meaning of what is R? R is distance from the source to the point of illuminance. Is that meaning of that is clear? Okay, the diagram. Okay, it is given in the question that there's a work plane and there's a point which is at the center of the work plane, and there's a light over here which is at 2 meter height on the wall. This is the wall, right? On the surface of the wall at a 2 meter height, there is a light that is pointing out. So it is in the light ray coming from the source to the center point of the work plane, that is making 60-degree angle this end. And the vertical height on the wall is given as 2 meter. That's all what we have as the information. Angle of incidence is 60. That is angle between the incident light ray and the surface normal. If this is 60, the remaining angle at the base of this triangle, that will be 30 degrees. Why? Because the total sum should be 90. That's the surface normal. So that's how I've drawn this diagram, from which by applying sine 30, we got the distance r. Is that clear, Angel? Okay. Thank you for the confirmation. Let us now look into a bit difficult one. A third question of the same inverse square law concept, but a bit difficult one. Make a note of, or actually, let me open that question onto the screen itself. Just give me a moment. Let me open the question for you on the screen. It's a question from GATE 2021. Just a minute. from GATE 2021. You can also have the question papers always with you. We're looking into GATE 2021 question paper where you have a numerical question on this concept of inverse square law, which is not so straightforward. So we'll look into that. Okay, before actually, there's one more concept you need to know in order to answer this question as well. So let me teach you that too, and then we'll solve the question. But let me just open the question first. Okay, let me first discuss that concept too, and then we'll look into that question. So there's one additional point for the upcoming question, which is also based on inverse square law, but there's one additional term you need to know to answer this question, which is also a term related to light and photometric properties itself. Write down that as point number 5 of your notes actually. That is the meaning of luminous efficacy. So let me just give me a moment. Right. Luminous efficacy. EFFICACY, efficacy. So luminous, write down the definition for this, and then we'll solve the third question. Luminous efficacy is defined as the flux emitted by a source per unit power consumption or per unit power. That's basically the definition of what luminous efficacy is. Write down the definition. Luminous efficacy of a light source. Luminous efficacy of light source. So you always define efficacy for a light source. Luminous efficacy of a light source is the flux emitted by it per unit power. Luminous efficacy of a light source is the flux emitted by it per unit power. So that's what luminous efficacy is. So basically, in terms of formula, you can write luminous. I'm not using any denotation for it. You can just write it as luminous efficacy. That is the luminous flux emitted by it per unit power consumption. For 1 watt of power, every light source will have a wattage. If you go and buy an LED bulb, let us say you go to a shop, you want to purchase an LED light fixture, a normal bulb. First thing the shopkeeper will ask you if you want a 9 watt or a 12 watt or a 15 watt. There will be different types of wattage for every light source, right? So that power we are talking about. So luminous, the flux numerator that is measured in lumen, and the denominator that is measured in watts, right? Lumen per watt. So luminous efficacy is measured in lumen per watt. I told you in the beginning, lumens can be converted, or there's a conversion factor between lumen and watt. That's the luminous efficacy. This is not a standard conversion. Lumen per watt depends on the source. For incandescent bulb, it will be different. Generally, it is approximately up to maximum of 20 lumen per watt. That's what you'll get in an incandescent bulb. So there are 10 different types of light sources. For each of it, luminous efficacy values are defined in the National Building Code. Where can you find the efficacy values? If you have time, you can just check it once in NBC 2016. The second volume, volume 2, part 8, section 1. This is the chapter where you will find the efficacy values for different light sources. For LED bulb, it is up to 100 lumen per watt. So depending on the type of source, it will be different. Generally for LED, it is in the range of 80 to 100 lumen per watt. For incandescent bulb, you will get only 20 lumen per watt. Why? Because LED bulbs are more energy efficient. Incandescent bulb will have a lot of heat losses generally. So the efficacy value is low for incandescent bulb. For different types, you have different values given. How is it different from intensity? Neha, it is different in this case that intensity of a source is flux emitted per unit solid angle. It has to do with the geometry of the light. Per unit solid angle, how much intensity is coming. Efficacy, on the other hand, this has to do with the functioning of the light. If it is an LED light or an incandescent light or a sodium vapor lamp, every type of lamp based on its function, it has to do with energy consumption, electricity consumption over here. In intensity, it has nothing to do with the wattage and all. Is that clear, Neha? So this depends on the type of source. You can find the values, like I said, in table. I think it is table number 8, if I'm not wrong. You can check once. There's a table with 10 different sources for which efficacy values are defined in this particular chapter. Additionally, you'll find the same table in the National Lighting Code as well. You can also download National Lighting Code as well for your reference. Now, given that this subject is not so major with a huge weightage, I will not recommend you to have a lengthy study of the National Lighting Code in full, because that itself is a very huge document. You can stick to the important points being discussed in the class. So that's the definition for efficacy, flux per unit power. That's basically, try to solve a simple, let us take up an example to understand better. A small question. Write down a question. A 9 watt LED bulb, a 9 watt LED bulb, a 9 watt LED bulb with flux output of a 9 watt LED bulb with flux output of 1000 lumen. A 9 watt LED bulb with flux output of 1000 lumen will have an efficacy of dash. Will have an efficacy of dash in lumen per watt, obviously. How much will that be? Flux emitted per unit power. So it's basically F upon power. Flux is 1000 lumen. Power is given as 9 watt. 111.11 you will get in lumen per watt. So that becomes the efficacy value of that LED bulb. So depending on the type of source, the power and the flux emitted by it, efficacy value will change. So that's the concept of efficacy. Let us now look into that question based on this concept of point number 5. Applying this along with the inverse square law, there was a numerical asked in 2021 paper. Let's look into it. Under the numerical questions. Question number 48. Try to answer this question. Look into this question. You need not write the complete question into your notes. Based on the information given here, write down the required values, draw the diagram, and try to solve it yourself. Are there any questions on color rendering index and efficacy values? What all to remember? Tanya, not at least in last 20 years, not a single question was asked on the standards of what is the efficacy or what is the color rendering index. Not in gate exams, such questions have not been asked. So in such cases, I would not say it is important, but you can have a look at it once briefly. Good that you asked, Tanya. So just to add to Tanya's question, what should you remember from that table of part 8, section 1 of NBC volume 2? Look into that table. There are 10 different types of light sources. Just have a look at it to understand which is having a higher efficacy, which is having a low efficacy, because efficacy tells you about how energy efficient that light fixture is. LED generally has a higher efficacy value. It means it is energy efficient light fixture. So just have a look at it, which is having a higher and lower efficacy value. Other than that, there is also color rendering index. So color rendition talks about how efficient a light source is in showing you the actual colors. So look at that. So read about color rendering index briefly. You need not remember any values. Understand the concept and see which is having higher color rendition, which is having low color rendition. And finally, important part is to know the application. So for street lights, what do we use generally? For cricket stadiums, what type of light sources use? So whatever sources are listed down in that table, just have a brief study of it with respect to applications. This area is not important. Had it been important, I would have discussed in the class. It's not important, but you can read about it briefly from your end once. Tanya, it is, as far as I remember the table number, it is 8, but you can check once. But I wrote the chapter number already. It is NBC volume 2. Part 8, which is building services, section 1, which talks about lighting. In that, check the third table of that chapter. That's where you'll find these values. Okay, Aparna has confirmed it is 8. Right. So that's what you'll need to look into. Okay. Fine. Answer this question now. A circular cricket field of 180-meter diameter is illuminated by 4 floodlight towers The floodlight towers are equally spaced along the perimeter of the field. The height of the floodlight tower is 48 meter. Using inverse square law of illumination level at the center of the field, using inverse square law, the illumination level at the center of the field is found as 750 lux. Each tower is having 50 lamps. The rating of each lamp is 700 watts. The efficacy of each lamp is dash lumen per watt. That's the question. So let me just write down the given information. Then I hope you have written down, looked into the question. So the diameter of the cricket field is given. There are 4 floodlight towers. They are saying that is important. 4 floodlight towers, and which are equally spaced along the perimeter. The height of the floodlight tower is given, and the illumination at the center of the field also is given as 750 lux. Each tower is having 50 lamps of 700 watt each. Each lamp is having 700 watt. Efficacy is being asked. Let us look into this question now, based on the given information. Just give me a minute. So it is clearly stated you need to apply inverse square law to find out the finally what is to be calculated. They want us to find out the efficacy value, right? So let us look into this question now. So this is circular. I'm drawing the plan. Let us say this is the circular cricket field. The center of the field is having 750 lux. They are saying the light level, and this 750 lux is equally contributed by 4 equally spaced lamps. Why is equally spaced important? Because if these floodlight towers are not equally spaced, then the distribution of illumination will not be same at the center. So the contribution of them will not be equal basically. So if these 4 are equally spaced and are contributing equally to the center, what will be the illumination contribution by one floodlight tower? Can anyone tell me? E at the center is 750 and there are 4 equally spaced floodlight towers. So what is the illuminance at the center due to one floodlight tower? It is 750 contributed by 4 lamps, so 750 divided by 4. How much are you getting that as? 187.5. That's the contribution in lux for every light, every floodlight tower. That's the first thing which is given. Other than that, some details. They have also said how they calculated this E, because there are two ways to calculate illuminance. To find out illuminance, you can find out the total flux divided by the total area of the field. That is one approach. They are saying that is not what they use. They used inverse square law to find out illuminance. That's clearly stated. And the diameter of this cricket field also is given as 180 meter. And in terms of, if I draw, let us say, so it's like there are 4 floodlight towers, right? Which are equally spaced, 1, 2, 3 and 4, which are all of same height, which are all contributing equally to the center. So if you take any individual floodlight tower and the contribution to it to the center, so if I draw this part, so similarly all the 4 will contribute, right? If I draw this right angle triangle of one particular light, let me draw the diagram. So if I draw a right angle triangle joining, this is the base of the floodlight tower, and this is the top of the floodlight tower. Or you can say center of the flood, because floodlight tower itself will have 50 lamps and there can be, so you can probably take the center point of that floodlight tower probably. So those intricacies are not involved in this question. They just said the height of the floodlight tower is 48 meters. And this is, let us say, the center of the field, cricket field. In this diagram, can anyone tell me, so this is a right angle triangle. In this diagram, can anyone tell me what is the height? What is this distance from the base to the top of the floodlight tower? That's given in the question. Think someone has a question, someone with a phone number. Which part is not clear? You need to be specific. That's when I can help you with your doubt. Someone who asked me to repeat. Please be specific. Which point is not clear for you? Formula? Okay. Are you talking? So what formula? Like I have not written any formula till now. Are you having a doubt on understanding which formula to apply? Is that a question? Okay, this one. E at the center due to one floodlight tower I have written. So if there are 4 floodlight towers which are together giving you 750 lux, what is the illumination due to one tower? There are two lights. There are a total of 4 floodlight towers, right? For each floodlight tower, it will be 750 divided by 4. That's what I have written. Okay, got it? Fine. So this is given in the question as 48 meter. Lavina, I've already showed you the question just a while ago. This is from GATE 2021, question number 48. It's a 2 marks question. I opened the question on the screen just a while ago. So the height is given as 48 meter. Can anyone tell me what is the base of this right angle triangle? Distance from the base to the center of the field, how much is that? The total diameter is given as 180, so this is going to be 90 meter, right? And this distance, this is the angle of, this is R. And what is the angle of incidence? Can anyone tell me in this diagram? This is the point of the field. This is the surface normal. Angle number one or angle number two? Which is angle of incidence in this case? Angle number one is angle of incidence. So this is angle of incidence theta. If this is angle theta, this angle also will be theta. Why? Because these two are parallel lines. If you have two parallel lines cut by a transverse, these angles, the corresponding angles will be equal, right? So the alternate angles will actually be equal. So based on that, this and this both will be same angle theta, right? So the top of the flat, so this is distance 48 and this is 90. You need to know R and you need to know cos theta to apply inverse square law. So what is the distance R? Firstly, how can you find out R in this triangle? If you, for any right angle triangle, if you know two sides, you can find the third using Pythagoras theorem. So apply Pythagoras theorem, hypotenuse is equal to square root of a square plus b square. Can anyone do that and tell me what is the distance R coming out to be? Applying Pythagoras theorem, you will get R is equal to 102 meters. How do you apply Pythagoras theorem? Hypotenuse is equal to square root of a square plus b square, it is 48 square plus 90 square. So simplify this using your calculator and you will get this as 102, as many of you have already calculated correctly. So R is 102. Other than that, so you know R, what is cos theta? Cos of this angle theta from this triangle. Cos is the ratio between the adjacent side and the hypotenuse. How much is that going to be from this right angle triangle? Cos of this angle theta will be ratio of the length of the adjacent side divided by hypotenuse. 48 upon 102. Cos theta is 48 upon 102. Other than these 2 points, I you have to calculate, because see, ultimately we need to find out the efficacy. To find out the efficacy value, you will need to know the flux of that light. To know the flux, it depends on the illumination level, so of the illumination created by it, right? So E is already given 187.5 lux. I'm taking individual lights one at a time. So I have E, R, and cos theta. From these 3 points, I can find out the intensity I of the floodlight tower. Apply E is equal to, apply inverse square law. E is equal to I upon R square into cos theta. You know the value of E. Substitute the value of E, 187.5. Substitute the value of R, which is 102. Substitute the value of cos theta, that is 48 upon 102. Substituting these three, you can find out the value of I. Calculate and tell me, anyone, what is the value you're getting for I? If you want, I'll write down that step on the board also on the screen over here. 187.5 is equal to I upon R is 102. 102 square into 48 upon 102. That is cos theta. Simplify this and tell me what is I. This implies I is equal to how much? 4145 343.75. Now, why is it important to solve gate questions? Because see, in the exam, if you are not having practice of sufficient number of questions, and when you're solving this question with such huge numbers in the examination, it is almost certain that you will get that level of, say, resistance from inside. Are you doing it correctly or not? How to face that resistance from inside? Only practice. There's no other shortcut. So practice as many questions as you can. Uh, sure, Vanshika, I'll repeat it for you. 4145343, right? 0.75. This is the value of I. After theta, you did not get. So, Vanshika, is this part clear that in this right angle triangle, R by applying Pythagoras theorem came out to be 102? Is that clear to you? Okay. And then you know what is theta also. So, cos theta also has been written. Okay. From here, I will tell you from this formula, right? A is given for some or all four lamps. So, Vanshika, it is given that the total illuminance is 750 for all the four lamps. There are four floodlight towers. Don't look at it as individual 50 lamps. There are 50 lamps here, 50 lamps here, 50 lamps here, 50 lamps here. Everything is a floodlight tower. So, every floodlight tower is contributing equally because they're all equally spaced from that center. So, what is the contribution of one floodlight tower? Will be 187.5. So, we're talking about the total intensity of the eye here. It is not intensity of one lamp. This is intensity of the floodlight tower. Total floodlight tower itself, all the 50 lamps together. Is that clear now, Vanshika? Are you able to follow? Okay, good. So I has the intensity of the floodlight tower has come out to be this much. What ultimately, so from here, this is where it can be a bit get a bit confusing. So try to concentrate. I hope till here there's nothing complex as such. So let me write it over here. Intensity of each floodlight tower, that is coming out to be 4145. How much was this? 4145, 343.75. That is in candela, right? So intensity is known. This is intensity of each floodlight tower. And what information do we have? That each floodlight tower has a total of 50 lamps. Other than that, it is also given that each floodlight tower is having 50 lamps and each lamp is of 700 watt. That's the wattage given. And ultimately, we need to find out the efficacy value, luminous efficacy of the floodlight, luminous efficacy of each lamp. Luminous efficacy will be the flux output of it divided by the power. So you can always, you can also think backwards as to what you finally want. This is what I want to finally apply. Power is already given 700. I need to find out the flux output of each lamp. So to get flux output of each lamp, I have the intensity. I don't have the flux of it, the total flux output of each lamp directly, but I know the intensity of the floodlight tower. Now, so if the intensity of the floodlight tower is this much, what will be the flux output of the floodlight tower? That depends on you can actually find out intensity of each lamp also either way. So let us try to find out what is the flux output of each floodlight tower. Either way, you'll get the same answer. F of what is the total flux of each floodlight tower? Total flux is I into omega. So ideally, this value of omega for that nature of propagation that has to be given in the question. So this is where you have to remember sometimes in the examination where you need to convert I to F. If the value of omega is not given to you, there are two ways to go about it. One, you can consider it as a point source, which you know in this case that it is not a point source. But still, you can assume it as point source with 4 pi steradian solid angle, or you can consider it directly as one steradian. Considering that, what is the meaning of one steradian? It is basically you're considering that all the light is concentrated towards that point only. So that's the meaning of it. So if I say intensity and flux, when will they be equal? I told you when omega is equal to 1 steradian, that's when these two values will be equal, I said. So what is the meaning of 1 steradian? It means the light is designed in such a way that the total solid angle is only 1 steradian and its total energy is used to illuminate only that particular surface. That's the meaning of it. So in the official GATE examination answer key of this 2021, marks were given for those who considered 4 pi also. Marks were given for those who considered 1 steradian also. So in the examination, whenever you get such questions, you can take 4 pi or 1. However, there are rare instances of it, but marks will be given for both the cases. So I would say you can take any of these two values. Probably you can take 1 steradian because there was one such question also in 2017 where the value of omega was not given, but still it was assumed as 1 steradian. So you can directly assume 1 steradian or 4 pi, whatever it is, you'll get the answer. Marks will be given to both. Uh, I wish you can do that absolutely. You can find out the flux first and divide by 50, or you can find out the I of each lamp by directly dividing this by 50 and then multiply it with 4 pi or 1 steradian, whatever it is. Both will give you the same answer, Ayush. Cos is 48 upon 102, Vikrant. In this diagram, Theta is over here, right? What is cos of angle theta? Cos is always ratio between the adjacent side to theta. This is adjacent side to theta divided by hypotenuse. So you have to look at this triangle from here, base upon hypotenuse. This is the base with respect to this angle theta. Is that clear, Vikrant? Okay. So moving on, let us complete this question. So I told you marks were given for both. Let us take omega as 1 steradian for a calculation purpose for now, but same thing you can do with 4 pi steradian and you'll get the marks also for that. So what is the flux output of each floodlight tower? F of each floodlight tower will be equal to the I itself, considering 1 steradian solid angle. This also will be 4145343.75, but instead of candela it will become lumen now, because I'm talking about flux. Why is candela value and lumen value becoming equal? Because I considered it as 1 steradian solid angle. That's the case I'm considering over here. Considering this will be the calculation. If the flux output of each floodlight tower is this much, what will be the F of each lamp? There are 50 lamps in each floodlight tower, so 4145343.75 divided by 50. How much is the lumen output of each lamp you're getting? Flux of each lamp? 82906. 82906 point something, 0.875. This is lumen. I'm taking the flux value here, right? Final step, what is the luminous efficacy? Luminous efficacy is equal to flux upon power. Flux I have calculated 82906.875 divided by the power is 700 watt. So what is the luminous efficacy in lumen per watt finally? 118. Absolutely, Ayush. There are two official answer key ranges. Marks were given for people who answered with 1 steradian. Marks were given for those who considered 4 pi also. Two answer key ranges were given in the official examination. 118.43. 118.4 something. 44 lumen per watt. Right? So this is one official answer. There are two official answer key ranges. Samhita, because in the question it was stated that each floodlight tower has a total of 50 lamps. It was stated in the question. You can check the question again. Question number. Is that clear, Samhita? That's the reason you did, because you're going to finally find out this is wattage of each lamp, of one lamp, right? So you need to find out the efficacy of each lamp, the flux of each lamp divided by the power of each lamp. Okay. So that's how you can do the same calculation by considering 4 pi also in this case. So F will accordingly become I into 4 into pi, and accordingly you'll get a higher value. That also was given marks in the official answer key. So that was about this concept. Please give me a confirmation. Is the concept clear to you all? J, no. You should not, or you need not type the value, the unit. See, in the NAT questions, the input box will take only numbers. So there is no comma, there is no number. So you just need to type the numerical value, digits from 0 to 9, decimal point, negative sign. These are the three inputs which the box will take in NAT questions. So you should not put any commas. You cannot actually put any commas, and you cannot also write the units. Angel, let me know when you're done. Previous to this, okay? Let me know when you're done, Angel. Any questions anyone has? Let me see. KZ, yeah, sine is 90 upon 102, but what is the point of taking sine? Because in inverse square law, the formula is E is equal to I upon R square into cos theta. So you have to take cos theta, right? That's the reason I've written down cos theta value. There's no point of taking sine. Is that clear? KZ? Okay. What else? Shruti has a question. If we have solved this using f upon a into cos theta formula, Shruti, firstly, it is not f upon a into cos theta. The formula is f upon a, that's it. In E is equal to f upon a will give you the average illumination of the overall surface. Into cos theta, you will get only in inverse square law. E is equal to I upon R square into cos theta. And you cannot solve this using E is equal to f upon a. Reason being, in the question they have stated that this is 750 lux considering inverse square law. So you have to solve it using inverse square law. Is that clear, Shruti? If we consider 4 pi, then the value is coming to be approximately 1400 something. Yes, Ayush, that's correct. How do we specify which angle is angle of incidence? Aisha, it is always defined like angle of incidence is always angle between the incident light ray. Now, what is the incident light ray? Say, whichever point is under, so this is the point under consideration. Let us say this is the point P where you are calculating illuminance. The distance from this point to the light source, that is distance R. Angle made by this line with the surface normal, that is always angle of incidence. So you need to always draw the surface normal to find out this is surface normal and this is basically the incident light. Angle between these two is called as angle of incidence. Is that clear for you? Ayush, I think it was you. Aisha, please, Aisha, not Aisha. Aisha, let me know if it is clear. Uh, any other doubts? Flux of each lamp is 82906. Yeah, Kalyani, it will be in the range. So few values plus or minus, that's perfectly fine. What was it I wrote over here? Yeah, flux was this much, correct. Can we find using Naren? I already said no, you cannot do it. You should not take the surface area of the circle and do it because in the question they stated that it is 750 lux. The value of E is given. E at the center of the stadium is 750 lux using inverse square law. That's what they said, right? So because by using F upon A, you will not get 750 because that's the average illuminance of the overall field. They're talking about the center of the field, a particular point. By using inverse square law, they have calculated. So you have to use that approach only. Hope that's clear, Naren. Uh, I wish that I'll need to see. I'll try to share you a practice sheet if that's possible from my end. I'll upload a practice sheet on the KPG Classes mobile app itself. You can practice the questions from there. I'll give you a practice sheet. Uh, what is the best way to approach when we don't know to consider 1/4 pi? That judgment makes us lose marks. Shall I the leave I to paper settlers or more preferable method or accuracy? Kartikeya, I would say you can consider one steradian accordingly proceed because even if in the official answer key finally if they're not giving you the range of that if it is not given marks, you can always contest it because there's a precedent. You have past gate questions where in such cases the value was taken one steradian and they have solved accordingly. So you can proceed with that approach. It is safe and say something where you will not you lose marks for sure. You can always contest in such cases if there's any discrepancy. So you can go with one steradian absolutely without any issue. Uh, Raju, absolutely right. Two ranges were given in the official answer key. Abhishek, no, one steradian is not 360 degrees. 360 degrees is for 2D circle. Steradian cannot be related to 2D circle. So that's not, both are different things. One steradian is not same as the sphere also because for a full sphere propagation it will be 4 pi, right? So not same. Prerna, probably you can text that on the faculty doubts number. We can have a personal discussion because it's not something important gate point of view at least. So we'll have a discussion on it of that concept you're talking about personally. Drop me a message on the faculty doubts number. Why did we not consider angle adjacent to the angle of incidence in the calculation? Okay. Neha, see, I hope I understood your question, Neha, correctly. Are you talking about this angle? Why did we not consider how much this angle is in the calculation process? Is that what you're talking, Neha? Okay. So Neha, this angle is not required for in the past question. We had to take that angle because to find out R, to find out this distance. But here in this question, you already know R. So what is the point of taking this angle and applying sine of it again? So you draw this angle, find this angle, apply sine just to find out. In the previous question, we did that. If you remember, in this question, why did I take that 30 degrees and apply sine 30 to find out R? But if I already know R from Pythagoras theorem, why will I do it again? Right? So it is just redundant. That's the reason I'm not talking about that angle. Is that clear, Neha? So it depends on what you're actually calculating, what you actually want in the process moving further. Okay, so that's about it. Let's now look into the next concept of lighting. That is calculating the number of lamps required in a room. That's the next concept, and one of the second most repeated area in the gate examination, other than inverse square law and F upon A. Other than these concepts, this is the second important area of illumination which we are going to study. That's with respect to the concept of the number of lamps. Take down the next heading. I think this is point number 6 in your notes. Number of lamps required to illuminate a surface. Number of lamps required to illuminate a surface. So calculating number of lamps, that is N, that's the next concept. I'll give you the formula and we'll solve some questions, but let me just give you a bit of background to it. Let us say, think in practical terms. Always, numerical particularly, you should always think in practical terms, and that'll make it easy for you to solve the question. Let us say there's a room or there's a surface area. Let us say this is a surface area which has to be illuminated, let us say, to a level of 200 lux. That's what you want on the surface. The average illumination you want on the surface, let us say, is 200 lux. Now, what will this depend on? Can anyone tell me in a room the required illumination level? What will it mainly depend on? How much lux you want in that room? What will that mainly depend on? The required illuminance. Absolutely right. It will depend on the activity. What are you using that room for? If it is a movie theater, obviously the required illuminance will be very less compared to what you read in a classroom where people are going to write notes, read from the notes. So depends on the task and the usage of that room. So like let us say the required illuminance of a room is 200 lux, and then let us say that there are a total of, or you want to find out the number of lamps. So number of lamps you don't know. You want to decide how many lamps you want to install in this room, and you know the area. Let us say the area of this room is 10 square meter, right? Now, can you even tell me from these 2 points of information? Uh, and let us also say one more thing. Okay, till now, based on these 2 points of information that the required elements is 200 lux and the area is 10 square meter. From these 2 points, can you even tell me what is the flux required in the room? Luminous flux required in the room. Total luminous flux required in the room. How much is that? F total. Total flux required in the room. How much is it? You know E is equal to F upon A. E is equal to F upon A. Area and E, if this goes to the other side and gets multiplied, you will get F. F is equal to E into A. So the total flux required will be E into A. 200 multiplied by 10. Because see, this is 200 lumen per square meter. Lux is nothing but 200 lumen per square meter. Multiply it with 10 square meter. Square meter gets cancelled. You will get the lumen value required. The total lumen value required, that is 2000 lumen. That's the total flux required in the room. Now, if I say each lamp is giving you 500 lumen, let us say that that's the flux output of each lamp. Can anyone tell me in this case how many lamps will you require to reach the total requirement of 2000 lumen? Will be 4 lamps. 500 plus 500 into 4, you'll get 2000, right? So what is the approach we are using over here? Number of lamps basically will be the total flux required in the room divided by the flux output of each lamp. Total flux of the room divided by the flux output of each lamp. That will give you the number. And how do you get the total flux output of required in the room? Total flux required will be E into A. Illuminance level in the room multiplied by area of the room. That E into A will give you the total flux required in the room divided by the flux output of each lamp. That will give you the number of the lamps required in the room. That's how it is. Now, one important point to be noted over here is, let us say this 500 lumen is the rated flux output of each lamp. Rated output. Let us say the company where you're buying from this lamp from. So every company will rate a lamp's flux output. Let us say they're rating it as 500 lumen. When you buy a light which is rated at 500 lumen, bring it, fix it into the room. Will you actually get 500 lumen right throughout its life after 50 days, after 30 days? Will you actually get 500 lumen in the room always? Obviously, no, I do not. So that is basically rated flux output. They have rated it in an experimental condition. When you install it in the room, the actual output you get might be different from what actually the rating was, right? So the actual output will be less. Why will it be less? It depends on a lot of factors. One, it depends on the room surfaces, the room shape. All these also will matter. If the room shape is something which has a lot of angles and small corners, that also will affect the distribution of the light. Other than that, the efficiency will also reduce due to dirt accumulation. Dirt can accumulate on the surface of that light and all, right? So due to these factors, there will be reduction in the output. So what we do is rated flux output, you don't use it directly. You will multiply it with some factors to find out what the actual output is. Right? So that's the context. So this is basically the derivation, the background of it. Using all these points, let me tell you the formula now. Now you'll understand the formula easily. So this is a simple background, and how we are understanding these concepts is important because in the GATE exam, always numericals will not be straightforward formula substitution. There will be some sort of intricacy or some sort of conceptual, twist, which they might add into the complexity, they might add into the question. So you have to understand the background also. So the number of lamps required in the room based on a on a derivation just now. Total flux output, that is E into A, illumination level required in the room multiplied by a surface area of illumination, divided by the flux output of each lamp, effective flux output, which is the rated flux output of each lamp multiplied by some factors. You multiply it with utilization factor and maintenance factor. So what are these factors? I will give you a definition of it just in a while. So write down this form. This is the formula you use for number of lamps required in a room or a surface. In this formula, let me list down what each of these terms are. The inputs required, 1, 2, 3, 4, 5 inputs. First, it is E. E is the required illuminance level for the room or for the surface of the room, right? The required illuminance level, that is E. Then you have A, that is the surface area of illuminance. Unless otherwise specified, you will consider the area of the floor as the illuminance. So if you have a room, you don't take the total surface area of wall, ceiling and all. By default, surface area of illuminance is taken as a work plane, and work plane is just the floor plane generally, because most of the works we do, we walk on the floor, we do our activity parallel to the floor. If you're writing something, right, probably there will always be exceptions. Sometimes you might have a installation on the wall or something, but those are exceptional cases. So unless otherwise specified, surface area of illuminance is taken as the floor area, or in actual terms it is the area of the work plane, which is a reflection of the floor area. Do we have to use the inverse square law for E if we don't have the value given? Ayush, it depends again on the given information. It's Ayush, right? Ayush, it depends on the given information. If I is given and distance is given, so simple thumb rule, if distance is given, inverse square law will be applied. That's where R comes into picture. If area is directly given, on probably is equal to F upon A will be used. So based on the given information, accordingly, you might need to come up with this value of E if it is not directly given to you in the question, right? So it depends on the information of the question. A is surface area of illuminance. F is the rated flux output. This is very important. Students generally go wrong over here. So remember this very carefully. It is rated flux output of each lamp. This each is very important. You don't take the total flux here. You need to divide it by the flux output of each lamp. Of one lamp you have to take. That's important. Other than that, you have UF, that is utilization factor. And then you have MF, that is maintenance factor. Utilization factor and maintenance factor. So utilization factor is basically, so both these values will always be less than 1. They can never be more than 1, because see, if you have a flux output of some, let us say 1000 lumen, after multiplying the maintenance and utilization factor, after factoring those values, the value will be less than that 1000, right? So it will not be more than one. Both these values, UF and MF, will always be less than one. What will it depend on? Utilization factor will depend on the room surfaces, room shape, room surface distribution. That's what it depends on. Maintenance factor depends on the dirt accumulation, deterioration of the filaments or the bulb fixture, depends on the maintenance factor. So that's the so these values, there's no formula to calculate them. The values will be given to you in the question. If the value is not given, you will not consider. You will basically take it as one. You will take, if maintenance factor is not given, you will assume it as 100% maintenance, best efficient maintenance. So you will take it as one. If the value is given, you will take whatever value is given in the question. So there's no formula. There are standards for sure, but from gate point of view, at least what the value will be given to you in the question. Whatever is given, you will take that. If that is not given, no other standard for you to remember. You can directly take it as one if it is not given to you in the question. So maintenance factor and utilization factor. So these are the two factors which are taken in. Let us practice a question on this concept, at least one question on this concept, so that you know how to solve questions from this aspect. Monica, yeah, absolutely. Maintenance factor actually depends on the air quality in that space. But you need not remember any standards for it, at least for the gate examination. They have never given such questions like the dirt level is very high, accordingly considered. So there are no standards for you to remember. Uh, if something is not given, you will take it as one. But if you're interested for sure, you can do your research. Every standard book, you will find the guidelines as to how much you have to consider if it is a very dirty room, if it is a clean room, how much you should consider. But I don't think it is important for you to remember values. Kalyani, the last half an hour will be for that. It's a small topic, so we'll have a discussion on it. We're almost done. After this, there's one more last concept of lighting, and then we'll look into solid waste. Uh, Total values of E, F, and A of 12 lamps together, utilization to be calculated. Then the number of lamps will be 12 for 1. I do not understand your question, but if you're saying that you know the flux output of all the 12 lamps together, you for sure will divide it by 12 and write F of each lamp. In this formula, you have to always substitute number of the flux for each lamp. So divide that total flux by 12 and write that, and number will be taken as 12 in that case. So that's how you need to do. But if you're taking the flux output of all the 12 lamps together, then you will take one. So it depends on what value you're substituting here. Right? Chalo, let's practice a question on this concept, and then we'll move on to the next topic. One question of this concept. This is also a past gate question. Just give me a moment so that I can write it for you on the board. Make a note of this question. This is a past gate question from the year 2015 gate exam. A classroom measuring 10 into 8 into 2. A classroom measuring, I'm just writing the dimensions. A classroom measuring 10 into 8 into 2.7. 10 into 8 into 2.7. They have said this is length, this is breadth, and this is height. A classroom measuring 10 into 8 into 2.7 requires an illumination level of 500 lux. Requires I'm writing in short as E. Requires an illumination level of 500 lux. On the desk level, using 40-watt fluorescent lamps. 40-watt fluorescent lamps. Using 40-watt fluorescent lamps with rated output of 5,000 lumen each. Rated output of 5,000 lumen each. Full stop. Assuming UF of 0.5. Assuming utilization factor of 0.5 and maintenance factor of 0.8. The number of lamps required is dash. See, there are some queries. Let me look into it. Sometimes I don't remember the exact question number. You can download question paper 2015. You'll find this in the numerical questions of it. What kind of theory topics you should focus on for theory questions, sir? Samhita, mainly the measurement units. Majority of the questions from lighting from the theoretical part have been related to the definitions and the measurement units. So that's what you need to do. But if you have additional time, probably you can go through the terminology from National Lighting Code. In the National Lighting Code, in the beginning of every chapter, you'll find some list of definitions. Probably you can read those definitions in addition to whatever we're doing in the class. Okay, I see many of you already have an answer. Let's look into this. So the classroom dimensions are given. The illuminance E is given as 500 lux. The flux output of each lamp is given as 5000 lumen each. Then you have UF and MF given. Number of lamps is being asked. Other than that, the area you need to know. Area of illuminance A. So to find out N, the formula is the total flux E into A divided by flux output of each lamp into UF into MF. Just 5 inputs you need. E is directly given, F is directly given, UF is directly given, MF is directly given. Area you need to calculate. Is there any significance of this 40 watt in the question? Is this information required? Absolutely no. So such additional information will be given. Someone says 5000 with 500 lux is the E given. I think it was Rishabh. So it's given as 500. Is that clear, Rishabh? Fine. So area, what is the area at the desk level? In this classroom, what is the area at desk level? Area at desk level will be same as area of floor level. So what is the area of floor level? L into B. So this height also is additional information, not necessary in this question. Right? L into B is 10 into 8, that is 80 square meters. So all the required values you have, just substitute into the formula and you get the number. E is 500 into area is 80 divided by 5000 into utilization factor is 0.5, maintenance factor is 0.8. What is the number you're getting? 20 is the correct answer. 20 lamps. 20 is the correct answer. Let me tell you within this question, now this is the answer for the question, but let me tell you one additional concept, one small concept in addition to this by using this question itself. So can anyone tell me, you have the wattage of each lamp given in the question, 40 watt is the wattage of each lamp. There are 20 such lamps. So what is the total power for the lighting system of this room? Can anyone calculate and tell me what is the total wattage, total power of the artificial lighting systems? How many watts is it? Total wattage of all the power. What is the total power of the lighting system used in this room? There are 20 lamps, 40 watt each. So 20 into 40, 800 watts. 800 watt is the total wattage. Now, one additional term you can remember here is light power density. There's a term called as LPD or light power density. So let me just write it in the next slide over here. LPD, light power density. Light power density of a room is defined as the total power of the lighting system of the room. You can write down the small definition, but light power density of a room is nothing but light power density of a room is defined as the ratio of total power of artificial lighting system, total power of the lighting system of the room to the surface area of illuminance in the room. That's called as light power density. Light power ratio of light inside to outside. We'll come to that, Monica. That's a different thing. Won't lux value differ with height? Absolutely, it will, Abhishek. But we are considering in this case that the total flux from all the lamps will reach onto that surface. That's what you're considering. But in practical terms, the light from it will also depend on the height, and accordingly, it will spread onto the walls, and light will also be distributed. But those intricacies are not considered in this calculation. For sure, in practical terms, but to get that exact value, you'll need to use simulation software, and accordingly, you'll need to develop contours of lighting systems and all. Anyways, light power density of a room is defined as the ratio of the total power of lighting system of the room to the total surface area of illumination of the room. In that previous question example, the total power of the lighting system we saw, that was 40 watt of each lamp into 20 lamps. So that total power was coming out to be 800 watts. And what was the area? Area of the work plane? 8 into 10, it was 80 square meter. So can anyone tell me what is the light power density value along with the measurement units? Tell me the light power density along with the measurement units. Light power density, it is the ratio of the total power requirement of the lighting systems to the surface area of illumination. How much is that? 10 watt per square meter. No, it's not 80, right? So this is getting cancelled. And 8 and 10, this becomes 10 watt per square meter. This is called as light power density of the room. So light power density is defined for a room. It is the ratio of the total power of that room, total light power, or total power of all the lighting fixtures of the room divided by the surface area. Why do we calculate it? What is the importance of it? This tells you about the energy efficiency or the scope of improving energy efficiency for lighting systems of a room. Can anyone tell me an answer for this? If you want to design a green building, an energy efficient building with an efficient lighting system, you as an architect, what will be your target? Will you try to increase the LPD or decrease the LPD to have an energy efficient lighting system? And if you want to design a green building where you want to receive a green building rating also, what type of lighting fixtures will you recommend? Will it be to reduce the LPD or increase the LPD? The light power density should be as low as possible. How can you reduce the light power density? Two things. One, you can increase the daylight autonomy. Daylight autonomy is nothing but depend using daylight efficiently. So if you are using daylighting by providing good windows and all, that is one way. Second, you need to use energy efficient lighting fixtures. Instead of incandescent or fluorescent lamps, you need to use LED bulbs, which are more energy efficient. So two ways, you need to use natural light and increase daylight autonomy, and accordingly at the same time you need to use energy efficient lighting systems that will reduce the light power density, which will give you the better say energy efficiency of the overall building, which obviously will be a sustainable building practice. So light power density is a tool which is used to analyze the efficiency of lighting systems of a given building from energy efficiency point of view. So that's about light power density. The last concept of this topic of lighting is daylight factor. Last point is with respect to daylighting. Daylight is nothing but natural light. So let us look into what is daylight factor. Write down the definition for daylight factor. Okay, first let me give you a brief idea of it, and then I'll give you the definition. So basically, if you have a room, let us say this is a room, and let us say you have a window over here from which you're getting natural light into the room, let us say to this point. The illumination without any artificial light, if I switch off all the artificial lights, let us say the illumination inside this room is EI. At the same time, the natural light available outside, let us say that is E naught. Can anyone tell me which one will be higher? EI or E naught, which will be higher? Obviously outside illuminance will be higher. So the daylight factor, it is defined as what is the inside illuminance expressed as a percentage of the outside illuminance. That's what daylight factor is. It is illuminance inside the room expressed as a percentage of the illuminance outside the room. Percentage, that's the reason you are multiplying with 100. Divide by E naught. So you are expressing the inside illuminance of a room due to natural light with reference to the outside illuminance available in this particular situation, expressed as a percentage. Generally, this outside illuminance that keeps on changing with times. At sunrise, it will be different. At noon, it will be higher. Depends on the cloud conditions and all. So generally, in practical purposes, you take an average outside illuminance. So that is also considered as design sky luminance. It is referred to sometimes as design sky luminance because design sky is a reference sky because sky conditions will keep on changing. Outside illumination will not be constant, it keeps on changing. If you take an average design condition, design criteria, that's called as design outside illuminance or design sky illuminance, right? Anyways, that's the definition. Write down the definition for what is daylight factor. Daylight factor or DF. Daylight factor is the ratio of, I'm not writing it on the screen, so make a note of it for yourself into your notes. Daylight factor is the ratio of, daylight factor is the ratio of light level due to natural light level as in illuminance basically. Daylight factor is the ratio of light level due to natural light, ratio of light level due to natural light inside a structure, the ratio of light level due to natural light ratio of light level due to natural light inside a structure, that is EI, light level due to natural light inside a structure, brackets you can write EI, to the light level, to the light level, to the light level available outside the structure, to the light level available outside the structure. This is inside, this is outside. Illuminance available outside the structure. As I said, this outside the structure, illuminance outside the structure will keep on changing. So you generally take something which is called as design condition or design sky illuminance. Design sky luminance also you can call it. So daylight factor is the ratio of light level to the natural light level due to natural light available inside a structure, that is EI, to the light level available outside the structure, E naught. In brackets you can write E naught. Expressed as a percentage. It is always expressed as a percentage. So into 100. Write down expressed as a percentage. Then write down this formula. EI upon E naught into 100. Ratio of light level inside the structure to the light level available outside the structure expressed as a percentage. EI upon E naught into 100. That's what daylight factor is. Let's try to, before we solve a question, let me tell you one additional point on daylight factor. Last point actually. This daylight factor. So basically, let us take up an example. Let us say the outside illuminance is 3000 lux. And let us say due to natural light, inside this room you are getting, let us say 300 lux. Or let us say you're getting 150 lux. Due to natural light, you're getting 150 lux inside the room. Now within inside the room, at every point it might be different. You generally take it as a desk level at a reference point generally. So can you tell me what will be the daylight factor in this case? If outside illuminance is 3000 lux and inside you're getting 150 lux, what is the daylight factor? Daylight factor in this example will be the light level inside the structure, that is 150 lux, expressed as a percentage of the lux level outside, that is 3000, expressed as a percentage. How much are you getting this daylight factor as? You're getting it as 5%. Daylight factor will be taken as 5 basically in this case. Generally, such huge daylight factor you'll not have, but then fine. You can take it as 5 daylight factor. So depends on the openings, depends on the windows you have, depends on the orientation. What will this depend on? It will depend on the orientation. It will depend on the sun path, depends on the latitude, longitude, the position of that particular building basically, the orientation of the windows, the size of the windows, depends on all these factors. The daylight factor in this example is 5%. Now this 5%, this daylight factor of 5% can be broken down into 3 components. So there are 3 components of daylight factor. That's the next point. After this definition, write down three components of daylight factor. There was a theoretical question also on daylight factor once. Three components of daylight factor. Make a note of the three components of daylight. Daylight factor is composed of this 5% is further broken down into three components. So so the three components, so let me draw a diagram. You will understand easily with that. Let us say this is a room. You have a window over here. So the daylight factor in this example, which was 5%, let us say the daylight factor is 5% here. This 5% is composed of three ways of natural lighting. One, you get light to this particular point, which is directly coming from the sky without any reflections. That is called a sky component. That is first component, sky component, which is that part of the daylight factor which is directly coming from the sky through the window, which is available. So depend, if there is no opening, then sky component will almost become zero, right? So you need to have a fenestration, you need to have something which will capture light. Sky component is that part of the daylight factor which is directly coming from the sky. Secondly, there will be externally reflected component. Externally reflected component is basically some light from the sky. It might be coming to some other external object. Let us say there's a tree. Light from the sky is coming to the tree. Then it is reflecting and reaching this point. So the light is not directly coming. The second component is that part of the daylight factor which is coming in due to external reflections. That is called as externally reflected component. I'll write down the three components once. Understand the concept. The third component is some light might enter inside due to external reflection source from the sky, but it might not reach this point directly. It will enter in, strike some internal surface. Let us say you're painting everything white in color. That will increase internal reflections. So due to those internal reflections, also the light will reach that point. So that's called as internally reflected component. That's the third component. So in simple terms, the daylight factor at a given point is composed of three components: sky component, externally reflected component, internally reflected component. Adding those three, you will get the daylight factor. So this 5%, it is possible in this example. So it depends on the sky conditions, depends on the orientation and so on. But depending on those conditions, this 5% can be of these three parts. Let us say 2% is coming directly from the sky. So 2 will be the sky component. 1%, let us say, is coming from external reflections. So the external reflected component will be 1%. The remaining 2% will be internal reflected component. So all these three together, there's no other way. These three things together will be daylight factor. So under the three components of daylight factor, write down this point that daylight factor is equal to sky component plus externally reflected component plus internally reflected component. This is the second one. Just these two things you have to remember for daylight factor. Sky component plus externally reflected component plus internally reflected component. Some of these three will be called as daylight factor. So that's about the concept of daylight factor. Let us solve one last question. There can be some additional pointers which I will list down towards the end, which probably are not very important we are discussing in the class, but you can cover it under yourself. I'll give a guide set of points which you can further study from your end. Let us solve one question. Tanya, like I said, we will try to limit over there because we have to study one more topic. However, I'll list down all the additional points you can cover. If you're not able to understand, you have the faculty doubts number, you can always drop a message and we are here to help you. I'll guide you through to understand what exactly it is or where are you getting confused, right? The question, let us look into this course. Vanshika, that's what I say. I explained you the concept. Try to solve it from your end. If you're facing difficulty, you can always reach out for help, right? Because see, there is limitation on what all we can do within a single class, right? We have covered all what is important, however. So this is a 2 marks question from 2018. Make a note of this question. The indoor illumination requirement for a building. The indoor illumination requirement. The indoor illumination requirement for a building is the indoor illumination requirement for building is 350 lux. If the daylight factor is 2.7, if the daylight factor is 2.7 and the design sky illuminance and the Design sky illuminance is 9,000 lux. 9,000 lux. Then the required supplementary artificial lighting. Then the required supplementary artificial lighting is dash lux. That's the question. And you try to do that. So I'll give you a 5-minute break after 5 minutes at 1:30. Right? We'll complete this lighting, then take a short break, then the solid waste management part. Indoor illumination requirement for the building is given as 350 lux. E required is given. The required illuminance is given as 350 lux. Furthermore, the daylight factor is given as 2.7. This will be illuminance inside the structure due to natural light divided by the design sky illuminance into 100. So this 2.7 is equal to illuminance due to natural light inside the structure divided by the illuminance due to natural light outside the structure, that is given as 9,000 into 100. So what is the illuminance due to daylighting in the inside the room? So illuminance inside the structure due to natural light only without artificial lighting, that will basically be 90 into 2.7. How much is this coming out to be? Something like 240 or so. How much is what? 90 to 2.7? 243 lux. This is what you're already getting due to natural light. The requirement is 350, of which 240 are already getting due to natural light. What is the additional requirement? Additional requirement will be 350 minus 243. So that balance of 107 lux, that is the additional requirement due to artificial lighting. That will be the answer for this question, right? 107 is the correct answer. That's how you'll need to answer this question based on this concept of what is daylight factor. So let us wrap up this lighting part by discussing few additional points which probably you can cover from your end also. So one thing, you can solve the questions. I'll show you a practice sheet which you can solve for your additional practice other than what we have done in the class. In addition to that, you can probably read, someone was talking about room index. Let me just write down the formula, but you can study about it for yourself. Room index basically is used to decide the mounting height or spacing, basically spacing to mounting height, or so mounting height is simply nothing but the height from the work plane to the level where the light fixture is installed. So that's what the mounting height is, and room index talks about that mounting height with reference to what is the level at which light has to be installed. Okay, you need not never questions have been asked in gate exam on this concept of room index. You need not write into your notes, but you can probably study about it. It relates to mounting height. So it's like length of the room multiplied by width of the room divided by the mounting height into L plus W. This actually is the formula, but not important for your exam as such. You can read about it further if you wish, right? So that's about that. Other than this, you can probably look into, someone was talking about a numerical asked on light power density. Sure, let me look into that. Let me know when you're done, Angel. Absolutely right, Tanmay. Luminance is measured in nits, which is candela per square meter. So you can read about what is luminance. So luminance talks about how brightly a surface is emitting light from it, or how brightly a surface is illuminated in a given direction. So luminance and illumination are different. There are no numericals as till date in luminance as such. So you can remember that also. Luminance. Luminance of a surface. Luminance of a surface is defined as the intensity of the surface per unit area. It is measured in candela per square meter, which is called as nits. Nit is the measurement unit. So you can read about this. So it tells you how brightly a surface is illuminated. If you have looked into specifications of mobile screens, laptop screens, I'm sure you might have looked into the specification before you purchase a smartphone. So you'll find these nit value of it. That so and so nits, the mobile screen is capable of a maximum luminance of so and so nits. That's what you'll find. That's where you use it generally. So it is luminance per unit area of the surface. Uh, can luminance? Absolutely, Akansha. Okay, because multiple students are asking. Let me discuss that last question and then we'll end the class. Let us look into that question of 2019. Uh, I think it was Vanshika also had doubt. Not wrong. Vanshika, right? So okay, let us look into that question. Last question and then we'll end the class. This one is a 1 mark numerical which was asked in 2019. Let us discuss this on light power density and then we'll end the class. The illumination level of a room is 300 lux. The illumination level of a room is 300 lux. That's given. And the efficacy of the lamps is 60. And the efficacy of the lamps is 60. Full stop. Light power density of the room is dash. Light power density of the room is dash watt per square meter. Ideally, in such questions, you will need to have the measurement unit of efficacy, but in the official question paper, that was not given. If it is not given, you will always consider the base SI units. Can you tell me what is the SI unit? What is the general unit we use for luminous efficacy? We looked into the definition. Not light power density. I'm talking about efficacy. Lumen per watt. Absolutely right. This is measured in lumen per watt. Ideally, that should be given, but they have not given in the question, so we'll assume lumen. So this is the question. Let us try to understand. The illumination level of the room is 300 lux. So this room, what is the meaning of illuminance? It is basically the amount of light you get per unit area. So basically, per unit area, that is 1 square meter of area of the room, how much light are you receiving? 300 lumen I'm getting per square meter. That's the meaning of lux. Lux is nothing but lumen per square meter. How much light am I getting per square meter? 300 lumen I'm getting per square meter. That's given. And the efficacy of the lamp is given. Each lamp, they are saying, can give 60 lumen per watt. By consuming 1 watt, it can give you 60 lumen. So what is the what is the light power density they're asking? So what is light power density definition? The power associated with unit area. So this unit area, it is receiving 300 lumen. For this 300 lumen, so to convert lumen to watt, you need light efficacy value. So convert 300 lumen, how many watts is this? 300 lumen in this question. 300 lumen is how many watts? 60 lumen is given as 1 watt. 300 lumen will be how many watts? Simple unitary method. 5 watts it will be. So 300 lumen is equivalent to 5 watts. So what is the light power density now? It is 5 watts per square meter. So the answer will directly be 5 watt per square meter. As simple as that. So basically, luminous efficacy is nothing but power associated with. So you can also remember that light power density can be calculated as the illumination level divided by the efficacy of the lamps. That also will give you light power density. So in this, what did you understand? That the illumination, that is E divided by the luminous efficacy, that also will give you light power density. I did not randomly use any formula. I explained you the concept. Unit area, 300 lumen it requires. That is converted to 5 watts based on the given efficacy. So 5 watts per square meter. Is that clear, Vanshika? You had a doubt in this? Vanshika and also who was the other one? Akansha. Can you please confirm, both of you? Someone has a doubt. Which point is not clear? Okay, let me repeat it again. Then give me a confirmation. I'm not sure what your name is. Own naam se aa raha hai account. So the given information, it is given in the question that the illumination is 300 lumen per square meter. This is given in the question. Per square meter, how much light energy you're getting? 300 lumens you're getting. And they're asking what is light power density. So basically you'll need to see that 1 square meter is dependent on how many watts of power. So how can you convert the flux to watt, lumen to watt based on efficacy? So that is also given for us 60 lumen per watt. So 1 square meter of area is receiving 300 lumen. So this 300 lumen, you need to see how many watts is it. For that, I use this given information of efficacy. 60 lumen is 1 watt, which implies 300 lumen will be 5 watts. So 1 square meter is dependent on 5 watts. 5 watts per square meter, that becomes the light power density. Is that clear? The person with the account phone, are you able to understand now? Okay. So let's take a 5 minute break and then we'll continue with the next topic. Be back in 5 minutes and we'll look into the basics of solid waste management. Particularly, we'll solve the numericals of solid waste management for the past few years. Whatever have been asked, we'll solve those questions. Akanksha, I'll upload it right away now in the break itself. So, Neha, these points, like I said, the definitions which I asked you to go through, this is what, and I gave you a homework also in the beginning, types of light fixtures, applications. That thing you can mainly cover. That I think should be sufficient. Right? Let's continue after 5 minutes. Okay, let us now continue with the next topic, that is solid waste management. Abbreviated generally as SWM. Let us so for this particular topic, we'll be spending approximately around half an hour. Weightage of this topic can be anywhere between 0 to 2 marks, and this topic will come under the common part of your official syllabus. Numericals and theoretical questions both have been asked in the past also. Numericals, not many. In last say 20 years, if you see, there are 3 numericals of it, of this particular topic. Other than that, you'll not get questions on this topic every year because it's a minor topic. However, after the change in the pattern, that is after 2022, because this is a common part subject, it is more highly likely that you'll get a question from it nowadays. Because uh, in the common part, you have highest weightage with highest number of questions in the examination. So almost every topic of common part can be considered equally important, even though it's small topics like this. So we'll have a revision of the way we'll approach this particular topic. We'll first revise some basic theoretical concepts of solid waste management. I'll tell you what else you can study from your end. Numericals particularly will solve all the numericals of past gate questions, whatever have been asked from this subject till now. We will be looking into all those concepts in the class right now, right? So that's how we'll be addressing this topic of solid waste management. Make a short note on some important theoretical points before we move on to the numerical concepts. Can you share a blueprint if you have? Salman, there's no notes which I have maintained. So, and that doesn't work also. If you take notes from someone, I don't think that will work out. It should always be a self-made notes which you have to study. So that's how you have to go about it. But again, I'll tell you there's a standard reference notes which you can refer to. I'll talk about that also. So firstly, for your self-study, other than whatever we are talking about in the class, there are 2 important documents which you can refer. Number one is the solid waste management rules published by the government, SWM rules of 2016, I think, and then recently 2024 publication also, I think, came out. So whatever SWM rules you can find out, you can refer to that. The PDF of it, I will share it with you on the app itself. You can refer to that. Other than that, in URD PFI guidelines, I did not upload the practice sheet in the break because it was a very short break, but right away after the class, I'll upload all the practice sheets and the reference documents which you can have a look at. URDPFI guidelines, volume number 1, in the chapter number 8, if I'm not wrong, that is physical infrastructure. In that physical infrastructure, you will find the subtopic of solid waste management. That's the second reference you can go to. Other than the class notes, these 2 things, if you refer, that is more than enough for the gate examination. Theory points particularly from URDPFI guidelines, volume 1, physical infrastructure chapter, solid waste management, that is one. And SWM rules of 2016. If you find 2024, so whatever is the latest one, I'll check and I'll upload that PDF for you. You can go through that as well. So these are the two documents which you can use under solid waste management for your self-study other than the class. Let us look into some important points which you have to remember for the examination. So as per URD PFI guidelines, there are standards with respect to, so basically, uh, who who basically governs, or in a given city, who manages the solid waste ultimately? Whose responsibility is it in a city? Can you even tell me in terms of level of governance, is it central government, state government, or the urban local body? Obviously, the urban local body level, that's what manages ultimately the solid. However, the guidelines and all can be like solid waste management rules. These are published by the central government. But then ultimately, at a governance level in India, it is managed by the local bodies, be it village, in case of village, it will be the rural local body. In case of urban bodies, it will be the urban local body. So municipal corporation or the panchayat, whoever is responsible, they will be basically handling the solid waste or ultimately. What is solid waste? Solid waste is basically the garbage. Many people are confused at this basic conceptual level. Also, many people think solid waste also includes the sewage. No, the waste which you get from the septic tank, that is all different. That is basically sewage. Sewage treatment is a different topic. We'll have a discussion of it on some other day. This lecture is focused only on solid waste management, and solid waste basically relates to the garbage and the refuse, garbage and the refuse related to that. That's basically solid waste management. When you go through the SWM rules, in the beginning, you'll have list of definitions. Everything is very clearly defined. What is garbage? There's a definition for it. What is dry waste? There's a definition for it. What is wet waste? There's a definition for it. You'll find all these definitions in the SWM rules. That's the reason I told you this is important for your reference, in addition to whatever we are doing in the class. So as per URDPFI guidelines, firstly, there are standards as to the rate of generation, how much waste is generated. In India, the range of waste generation for urban centers is generally zero point 0.2 to zero point 0.4 kg per capita per day. That's the range. However, for residential areas, so URDPFI guidelines defines the solid waste generation based on the land use. So for residential areas, the rate of waste generation is given in URDPFI guidelines as 0.3 to 0.6 kg per capita per day. For one person in one day, they generate around 300 to 600 grams of garbage or solid waste basically. So that's for residential areas. For commercial areas, the rate of generation of solid waste as per URDPFI guidelines, it is given as 0.1 to 0.2 kg per capita per day. That's the range of waste generation, if I'm not wrong. Let me be 100% sure on what I'm writing. Yeah, that's the range for commercial refuse, and then for street sweepings it is given. So Amit, I was just writing down the guidelines. That's it. For as per URDPFI guidelines, this is the rate of generation of garbage for street sweepings, and also for institutional areas. It is 0.05 kg or 0.05 to 0.2 kg per person per day, per capita per day. These are the guidelines which are defined. So whenever a local body designs the solid waste management system, they first need to know how much waste they are going to handle. So the quantity of waste handling, that depends on the population. So these are the guidelines set down by URDPFI guidelines based on the population per person per day. This is the range. So other than this, you can remember for you also have standards in CPHEO manual, which also states for urban centers, other than these based on the land use, it is also you have a guideline on the rate of waste generation for urban centers in India. It is taken to be 0.2 to 0.4 kg per capita per day. And for metro centers, metropolitan centers, the rate of waste generation is half a kg per capita per day. This was asked in the GATE examination once, this point. What is the waste generated by metropolitan cities in India? It is half kg per capita per day, half kg per person per day. So these are also additional guidelines you can remember with respect to CPHEEO, Central Public Health Energy. So there's a full form to it. CPHEEO manual. As per this, the urban centers have a rate of waste generation of 0.2 to 0.4 kg per capita per day. Metropolitan centers have half kg per capita per day of waste generation. So these are some guidelines with respect to how much garbage people generate in India on an average. That said, now coming to the management, the process, let us have a brief discussion on the theory pointers with respect to solid waste management. Then we will look into the numerical part, like I said. So let us look into the overview of the overall process of solid waste management. The ideal process of the solid waste management. So solid waste management guidelines are generally based on the principles of 3R. The 3Rs of solid waste management are reduce, reuse, and recycle. There was a question once on the sequence also. The 3Rs of solid waste management, not just understanding the full form, but you need to know the sequence also. It is always in the sequence: reduce, reuse, recycle. The meaning of this is people who are generous, unlike other services like water supply and all, water supply, electricity, gas lines, these will be supplied to the house. But solid waste and sewage, that is generated by people. We generate it and then dissipate it outwards. And the municipality has to take it from us and then handle it, right? So solid waste. So it is reverse flow. So reduce is the first step. Reduce is people should be responsible and reduce less garbage. That's the meaning of reduce. Reuse, whatever can be reused, you have to reuse it without any. So what is the difference between reuse and recycle? Recycle is you have to take it to the factory and then recycle it, like plastic, glass, they can be recycled. Reuse, on the other hand, it is using it without taking it to a factory. So this is less energy intensive. So firstly, you have to reduce the waste at your end. Secondly, whatever can be reused directly with minimal, say, changes to it, or with minimal cleaning or whatever, say, processes are involved, that is reuse. Recycle, finally, it is taking it to a factory and recycling it altogether. So paper can be recycled, glass can be recycled, plastic can be recycled if it is of particular quality. Single-use plastic cannot be recycled, and that's the reason single-use plastic is generally banned across in different areas and municipalities. So basically, reduce, reuse, recycle is the guiding principles of solid waste management. That's point number one. Coming to the overall sequence of steps, there are three major steps, or say four major pointers in the overall process of solid waste management, you can say. First one is the segregation at source. Solid waste management does not start at the government level. It's not done by the local body. The starting at least, ultimately they are the ones who basically carry on the overall processes. But it starts at a personal level. First one is segregation at source. The step number one in solid waste management is segregation at source. Segregation at source is nothing but you have to segregate the waste into different categories, mainly dry waste and wet waste. That's the major categorization. As per the guidelines of SWM rules, uh, so it's a general practice that dry waste goes into blue bins and wet waste goes into green bins. That's the general, so that is called a source segregation. Segregation at source is basically segregating waste into dry waste, which is generally associated with blue bins, and then wet waste, organic waste, which is rotting matter. Generally, that is green. Why is this important? Because all the types of waste cannot be handled at the same manner. Wet waste has some other types of treatment processes. Dry waste can probably be recycled and reused. So it depends on, based on the type of waste, also the process of handling it will change. That's the reason segregation of source is important. Dry waste, wet waste are blue bins, green bins. Other than this, there's a third category of black bins. Probably you can check about it for other waste, including say probably hazardous waste category. So there's another bin for it. But these are the two major categories under segregation. So you can check this segregation from SWM rules mainly of 2016, the document for which I will share with you. Other than that, even in URDPFI guidelines, a categorization is given, which actually is based on the old version of SWM rules. So if you check URDPFI guidelines, they refer to the SWM rules of 2000, the older version. But in 2016, the color coding has been updated. So in URDPFI guidelines, you'll have black bins, blue bins, and probably green bins. something of that sort. But in the updated rules, you have blue, green, and black. So refer to the updated version. That I think will be better. However, you can have a look at both the SWM rules and also the older ones, including the UIDPFI guidelines. However, the first step in solid waste management you have to remember is segregation at source based on the type of waste which has to be segregated into different categories, which has been defined in the SWM rules in India. So that's the first step. Now, in particularly developed countries, probably in some European countries, probably like Germany, they even have a even more detailed level of classification into probably 5 or 6 categories. But in India, you have mainly those 3 categories like dry, wet, and other hazardous waste. Those are the 3 categories as per segregation as per SWM rules is considered. Point number 2. Once the waste is segregated and generated at the source, that has to be collected and transported. So the second step will be collection and transportation. Collection and transportation. What is the difference between collection and transportation? Collection is basically at a street level, at house level. Collection can be of 2 main types. There is doorstep collection. Doorstep collection is where the municipality or the van which collects the garbage will come to the street level on daily basis or alternate day basis. That's called as doorstep collection. The second type of collection method followed in solid waste management is community bins. However, community bins have their own challenge, because if you have a community bin, people dump the garbage, and if that community bin is not cleaned at regular intervals, if there is a break due to some reason at some points of time, it will start spilling onto the street. And someone who has their property near that community bin, no one will want that. No one will want a community bin to be in front of their house in solid waste. Let us say if in a street there's a community bin, and if they're installing it somewhere, obviously the people around it will basically oppose it, right? So there's a concept in urban planning which relates to this policy framework where people try to oppose some new policies or some rules of this sort, which is called as NIMBY, not in my backyard. You might have heard about this. Not in my backyard. That's a concept related to the opposition given by people for some policies, which can be as simple as establishing a community bin in a given locality too. So there are some challenges you can remember basically with respect to collection. These are 2 broad types of collection: doorstep and community bin collection. As far as transportation is considered, transportation is carrying this waste to a treatment facility and basically for the next process, like the treatment of solid waste done by the municipality. And finally, where does this solid waste go to? It will end into a landfill. So transporting it from the community bins or from the centers throughout the city to an outskirt point where it is probably going to be treated. The waste has to be treated and then disposed. So that is called as transportation. Transportation is basically carrying it from the city center to the outskirts where the waste will be further subjected to treatment and disposal. Right? So this process is called as transportation. Collection is within the city. Transportation is from the city to the outskirts where treatment and disposal will be conducted. That's the second step, collection and transportation. There was one numerical under this transportation part asked in the gate examination once with respect to number of trips required. So how many trips are required by a truck to carry the waste? All this depends on the quantity of waste, depends on the compaction involved in it. So these are the factors. We'll solve the numericals, you'll understand better. In an overview, that's the second step. The third step in solid waste management, after collection and transportation, you'll have treatment processes now. Treatment, recycling and treatment, you can say. 2 things. If the waste can be recycled, that will be recycled. Like I said, glass, paper, or say even plastic, some types of plastic that can be recycled. So that will be taken to a recycling facility. So if everything is segregated, because see, segregation at this level will be very difficult. So segregation is ideally done at the source itself, and then the waste which can be recycled is taken to the recycling facility. Whatever cannot be recycled can be further subjected to treatment. Under recycling and treatment, there are various processes, including so you can directly take the some types of waste for recycling like plastic, paper, and say I gave you those examples, glass. Other than recycling, there are also additional innovative techniques like refused derived fuel, RDF. So From that refuse, from the garbage, you can use it as fuel for generating electricity and so on, right? Sure, Prerna, let me know when you're done. So refuse derived fuel. Other than that, you have processes like pyrolysis, you have incineration, processes like incineration can be used. So all these come under recycling and treatment, mainly the treatment processes. Incineration is a process where the waste is burnt in the presence of oxygen. That's called as what is incineration? Solid waste with garbage basically burnt in the presence of oxygen is called as incineration. There are incineration plants where the waste is burnt basically, and in the process of burning, you can use that energy for producing electricity or so. Heat is required for making electricity. So that is refuse derived fuel concept itself. So incineration is where the waste is incinerated as in basically burnt in the presence of oxygen. However, there will be associated challenges with it, mainly the pollution associated with it. Ritik, RDF is refuse derived fuel. Using the refuse as fuel, it is similar to this process of incineration itself. Other than that, refuse derived fuel can also be process of biomethanation. If it is rotting matter, you can use it as in a biogas plant to generate methane, right? So that's all these are types of refuse derived fuel. You're using the fuel, you are using the refuse as fuel. I hope that's clear, Ritik. Incineration, then you have pyrolysis. So these are some technical terms associated with recycling and treatment, basically. You can remember pyrolysis is it is a type of waste treatment process wherein the waste is subjected to thermal decomposition. So these are thermal processes, both of these. It's a thermal decomposition process, which is wherein the waste is subjected to higher elevated levels of temperature in the absence of oxygen. That's what in pyrolysis is. It's a thermal treatment of solid waste where the waste is subjected to elevated temperatures in inert environments. So basically, in the absence of oxygen, you can say in the, or you can write it as in inert environments. So there's no presence of oxygen. You're not burning the waste. Rather, in an inert environment, there are specific chambers constructed for it. In that, the waste is subjected to elevated temperatures, which is a thermal treatment process. In this process, what you get of pyrolysis is the waste basically gets converted into something called as biochar. And that biochar is a type of charcoal which has its own application. You can use it as fuel or you can use it for filter beds like activated charcoal filter beds. So from the pyrolysis process, what you get out of this process is biochar generally. It's called as biochar. It's a type of charcoal which can be used for other applications. So incineration, pyrolysis are some examples for thermal processes, thermal treatment processes. Why are they called as thermal? Because we are having elevated levels of temperature in these processes. Other than thermal processes, there are biological processes also. Thermal processes of treatment, incineration, pyrolysis. As far as biological processes, biological treatment processes, main example for this can include biomethanation. In biomethanation process, basically it's like composting. Rather than this, composting also is an example. Biomethanation, composting, all these are biological processes. Vermicompost also you might have heard. Vermicompost. Vermicompost involves using earthworms basically. All these definitions will be more clear for you when you read the terminology of SWM rules. I told you in SWM rules, I'll show you the document. Just read the definitions. That itself will give you a lot of information. All these definitions have been included over there. So vermicompost is using earthworms to decompose the rotting matter. Now these biological processes are mainly used for wet waste. right? Wet waste like rotting matter, that's where you can use it. What is the other two processes? Composting, you know what? There are different types of composting. You have windrow composting, wherein you lay the garbage in rows and you mix it with air. Aerobic bacteria is used in this process to create compost, and that compost has its own application. You can use it as fertilizer in plantations later on, right? So composting, vermicompost, these are some process of biological process, and biomethanation is a special type of process where the organic matter is subjected to anaerobic digestion that releases methane, which can be used as biogas. In biomethanation, basically C6H12O6, that is the sugars present in simple terms in the solid waste, the wet waste, that when it is subjected to anaerobic digestion, that releases carbon dioxide and methane primarily, CH4 and CO2. To have a balanced equation, you can write three molecules of both these gases. So these are also referred to as landfill gases. Dishant, it was biochar. C6H. So this is the basis of the process of biomethanation. So this gas which you get in this process of biomethanation, wherein the wet waste which can rot in the anaerobic conditions, that is in the absence of oxygen, bacteria will break. Why are these biological? Because you're using biological organisms in these processes. That releases methane and carbon dioxide, which both of which are also called as landfill gases. Because if you don't have proper treatment done, these gases will be released in the landfill site, and this CH4 is called as methane. Actually, approximate. Now, this is not standard, depends on the quality of the waste, but generally 70% of this gas will be methane, 30% of the gas is generally carbon dioxide, and methane, as you know, is a flammable gas and can be used as fuel. That's the reason it is called biomethanation. You're producing methane, which can be used as a flammable gas, as a fuel, basically. It's also called as biogas in general terms, right? So these are some biological processes. Other than thermal and biological processes, there are additional physical processes also for solid waste management, which include, I'm sure you might have seen across in news, sometimes people come up with innovative techniques wherein they shred plastic, compress it to make bricks out of it. Some people shred plastic and lay roads out of it. That has been done. There have been innovative applications of recycling the material to make new, say, fabric, shoes, recycled shoes. So all these are innovative applications of physical processes. 0 to 2 it is, yeah. So there are physical processes. Under physical processes, you can also remember one other process called as pelletization. Pelletization is a process where the refuse is shredded into small pieces and compacted into pellets. Compacted into pellets. Pellets are like small, say, balls or small bullets. These itself can be used as a fuel then. So waste, dry waste is shredded into small pieces, compacted into small pellets. These pellets can be used as a fuel to burn and get energy out of it. So that's also a process. So these are some broad processes involved in recycling and treatment in simple terms. What type of gas are methane? Aman, I said that these gases, methane and carbon dioxide, are also called as landfill gases. These gases are also called as landfill gases. Why? Because these gases are also released in the landfill sites. Now that's actually the fourth and last point. After recycling and treatment, after all processes, whichever are suitable can be used. Uh, Physical process, Neha. It's not biological, it's not thermal. It's a physical process because there is no biological organism or temperature involved. Just a physical process. You're shredding and compacting. So it's a physical process. So these are the three broad categories under recycling and treatment. Other than this, I was telling you with respect to the fourth step, fourth and last step, that is disposal. Disposal is generally done after treatment. Basically, this has to be done after treatment because in the treatment process, recycling and treatment process, you're going to use as much as you can. The waste you're using it as much as you can, you're recycling it as much as you can. After doing everything, whichever cannot be recycled anymore further, that has to be disposed of after the treatment, which is generally done in landfills. And with respect to landfills also, there are some important points which have to be kept in mind. If you have visited, if someone is from Delhi NCR or has visited any outskirts of Delhi, I'm sure you know that you don't have any huge hills and so on in Delhi. There's only one hill, and that is a garbage hill, which you found in the outskirts across in Delhi, right? So, landfill management in itself is a huge issue in major cities, metropolitan cities, particularly like Delhi too, faces a lot of problem with respect to it. Otherwise, landfills keep on increasing in size, and that will add to you will keep on making new landfill sites. You'll be losing a lot of land for it. The surrounding areas also will start to face difficulties due to that, right? So landfill management in itself is difficult. So points to be taken care of, key points which are to be remembered with respect to landfill management include: firstly, there has to be proper compaction in layers. Landfills are generally laid down in layers with proper compaction. Other than that, there are always interlayers wherein what will happen of that landfill? Nothing, I think it will keep on growing in size. No, nothing else happens unless some new innovative technique will come to recycle that waste. Landfills keep on growing. That's what happens in cities. So that's the reason taking care of recycling and treatment in a best possible manner to reduce these layers, that is important. And now, if you think what is the best practice, what do developed countries do? They try to focus and invest on recycling and treatment. And there are instances where developed countries, particularly in the Europe, they have shipped shiploads of garbage to underdeveloped countries, particularly in Southeast Asia and so on. That has been happening also. So that in itself is a huge challenge where people send where people, small countries which are not very developed, they take money and take garbage with it. So just for taking garbage onto the country. So that also has been a major issue at an international scale. Uh, if you follow news, probably a couple of years ago, this happened with China, with Canada. Canada sent few shiploads of garbage to some Southeast Asian country, and it was all over in news. The huge international uproar happened. Anyways, there are challenges involved in solid waste management. We might think that it's a small thing, but it has global implication, like I said. So proper compaction into layers, that's one important aspect of landfill. Other than that, landfill gases, management of landfill gases. For this, generally methane channels are laid down in the landfill. Some pipelines or channels are laid down to capture methane. Why is it important to capture methane? Because methane is a flammable gas. And methane, because it is a flammable gas, it is associated with fire hazards. If you follow news, multiple times it has happened in Delhi that landfill sites will experience some fire hazard, and there will be a fire accident, waste will start to burn. Why will that happen? Mainly due to presence of excess methane. How can you avoid this? One, you have to lay methane channels. Two, you have to properly treat the waste before disposing. If you properly treat the waste, if you use this biomethanation process to 100% efficiency, obviously there will be no more methane generated at the landfill site. So these are some aspects to be taken care of. Other than this, leachate management. Leachate is basically a highly polluting liquid which is highly polluting in nature and also dissipates a lot of bad smell. So generally in landfill sites, leachate is basically a high BOD. BOD is nothing but biological oxygen demand. It is a measure of pollution. So high BOD, or you can say highly polluting, or in technical terms, you can say high BOD liquid which comes out of the landfill sites. How can you manage this leachate? Generally, HDPE lining is done on the landfill sites, surroundings of it at the bottom before you start constructing or laying down the landfill. It has to be lined with HDPE membranes, high density polyethylene membranes. It's a polymer membrane. HDPE membrane lining is to be done on the landfill sites to avoid groundwater contamination. BOD is biological oxygen demand or biochemical oxygen demand. Both are correct. Biological oxygen demand or biochemical. It's a measure of pollution. We'll study this and see where if time permits that day. So leachate management is where that liquid which comes out of, so it has a lot of bad smell and also it leads to groundwater contamination. So HDPE membrane lining, this will help in controlling the groundwater pollution. It helps in, it avoids groundwater pollution. Not only these points, there are many other points, but these are some basics you have to remember. In fact, landfills, the location of landfill is to be decided in such a way that it is far away from airports, because landfill sites generally lead to growth of rodents, rats, and so on, due to which high flying birds, particularly eagles, are attracted. So at this landfill sites, I'm sure you might have seen, there are a lot of eagles and high flying birds that interferes with the flight activity. So generally landfill sites, while deciding the location in the city, they have to be located as far as possible and should not fall into that pathway of the airport traffic, right? So air traffic particularly. So those aspects also have to be taken care of with respect to the location of a landfill site. So that's a broad idea on the 4 steps of solid waste management. With that, let us look into the numerical portion, the numerical questions which have been asked in the GATE examination, and we'll end the lecture. So probably 15 more minutes, and we'll end the lecture with it. Let's look into the numerical. I gave you an overview of all the theoretical points which are important. Make a note of the numerical questions which we'll be practicing. The first one, this is a 2 marks question from GATE 2022. There's a question in 2024 also, we'll come to that. But first, let us look into this question. A town with 0.45 million population, a town with 0.45 million population, town with 0.45 million population sends its entire organic waste to a composting site. Sends its entire organic waste to a composting site on daily basis. On daily basis. Through a truck of 15-ton carrying capacity. Through a truck of 15-ton carrying capacity. 15-ton carrying capacity, full stop. Assume total waste generated per capita per day. Assume total waste. Assume total waste generated per capita per day. Total waste generated per capita per day is 0.21 is 0.21 kg, and 40% of the total waste is organic waste, and 40% of total waste is organic waste. Full stop. So that's the question statement. Last point. The minimum number of weekly round trips. The minimum number of weekly round trips. Minimum number of weekly round trips required by the truck is dash. Required by the truck is dash in integer. So don't want an answer in decimals, you have to give an answer in integer as per the question. So that's the statement. A town with 0.45 million population sends its entire organic waste to composite site on daily basis through a truck of 15-ton carrying capacity. Assume total waste generated per capita per day as 0.21 kg, and 40% of the waste is organic waste. How many trips do you need? First thing is you need to see what is the quantity of waste generated. What is the total quantity of waste generated on daily basis? Daily basis, how much waste is generated? It is given as 0.21 kg per person per day. 0.21 kg. This is for one person for one day. For daily basis, for the total town, how much is it? 0.45 million. So this you have to multiply it with 0.45 million. Can anyone tell me how much is million? 10 to the power of how much is called as million? 10 to the power of how much? How many zeros? 10 power 6 is called as million. Absolutely right. So 0.45 million is 0.45 into 10 to the power of 6. 1 and then 6 zeros. So this decimal point will move forward by 6 places. How much is this population now? In lakhs, can anyone tell me? 4 zeros you will have. 4,50,000 is basically 0.45 million, right? So what will be the total quantity? 0.21 into 4,50,000 is the population. So what is this quantity of waste you're getting in kg? Can you tell me? Can anyone tell me how much is 0.21 into 45,000? 9,45,000 kg. You're getting a waste of 9,45,000 kg on daily basis. But all of this is not going to the composting site. Only 40% is organic waste. Remaining that's dry waste, they are recycling or treating basically. So what is the total quantity of organic waste to be transported? To be transported. How much is it? 40%. 40% of 9,45,000. How much is that? 0.4 into 9,45,000. How much are you getting? Okay, it's 94,500, not 9 lakh. Okay, fine. I did not calculate it from my end. So I think you are saying 94,500. Is this correct? 94,500, is that correct? Okay, the 40% of that, 94,500, 40% of that is 37,800. 37,800 kg. How many tons is this? 1 ton is how many kg? Can anyone tell me? When nothing is mentioned, you will consider it as metric ton. You will not take imperial ton. Metric ton, 1 ton is 1000 kg. So in tons, how much is this? 37.8 tons. This is the quantity of waste you have to transport on daily basis. 1 ton is 1000 kg, correct? So this will be 37.8 tons. So how many trips will you require on daily basis? How many round trips do you require on daily basis? This has to be transported on daily basis, they are saying. On daily basis. So if you want to daily transport this much, how many trips will you require? One trip, 15 tons. Second trip, 30 tons. Third trip also will be required because it is 37. So this will basically be 3 trips per day. Because 2 trips will not be sufficient. You're having a 15-tonner vehicle. You're having a 15-tonner truck. 3 trips will be required every day. In the questions are asking weekly round trips. How many trips per week you're going to have? In 1 week, you'll have 7 days. So you will have 21 trips, round trips per week. That's the correct answer. You should not convert this weight onto weekly weight of the waste, mainly because they have given in the question that the waste is transported on daily basis. So you have to first calculate the daily trips, then multiply it with 7. I hope that's clear. 37 point, it's not kg sometimes, it is ton. 37.8 ton. That's the weight generated every day. And in the question they're saying there is a truck which is carrying, which is having a capacity of 15 tons. So it's like this. One trip, how much waste you can carry? It can carry 15 tons. In one trip, you can carry 15 tons. How many trips are required for 37.8 tons? Simple unitary method. X will be this into this divided by 15. 37.8 into 1 divided by 15. Cross multiplication. This will be 2 point something. So that will be 3 trips. Is that clear, Santa? Okay. It's mentioned round trips. Do we need to divide it by 2? Ocean, it is mentioned as round trips. So if it is mentioned over here, uh, where is the term used over here for round trip? If instead of here, if they said trips, probably in that case you need to multiply it with 2 because it's going and coming. But they have clearly used the word round trip, so there's no worry with respect to it. Hope that answers your question, Ocean. What's written after total quantity of organic waste to be transported? Aparna, I've written transported over here. Any other doubts in this question? Anyone of you having any further query? Hope no. Chalo. Let's look into the next one. 2 marks numerical from 2024 paper. Let me open the question paper onto the screen for you. Just give me a moment. Aman, no. Because see, in 2 trips, how much waste can you carry? 15 plus 15, 30 tons. But you have to transport all the waste, right? You cannot keep the remaining 7.5 tons with you. So even the third trip is not a full trip, you have to end up having a. So even if the value is 2.1, you have to round it as 3 trips. Because even 0.1 ton also, even a bit of waste, you cannot. You have to transport it on daily basis as per the question. Hope that's question. That's clear. Okay. Let's look into the next one. This is a 2 marks numerical from GATE 2024. So you can open in GATE 2020. I'll open the question right away, rather than writing it completely. This one. It's a 2 marks question from GATE 2024. Try to answer this. Question number 49 of GATE 2024. A municipal town requires a volume of 70,000 cubic meter of compacted solid waste to fill a low-lying land. The city has a total of 10,000 households, of which 30% are LIG, who are producing zero point 0.1 cubic meter of waste per day. 60% are MIG houses, which are generating 0.15 cubic meter per household per day. 10% of the houses are HIG, which are generating 0.2 cubic meter of waste per house per day. This is volume of compacted solid waste already that is given. Using the information, estimated number of days required to fill the land. So what is the total waste we want? 70,000 cubic meter we want. How many days will it take? So for this, we need first calculate what is the volume of compacted solid waste per day. That's what you need to do. Try to answer that. It's a very simple, straightforward question. First thing you need to know is how many houses you're having. How many LIG houses are you having? 30% of 10,000. How much is 30% of 10,000? 0.3 into 10,000. So 3,000 you're having LIG houses. How many MIG houses are you having? 60%, that is 6,000. How many HIG houses you're having? 1,000, 10%. Once you have the number of households, multiply it with the volume, you will get the waste generated by the LIG houses. So total waste generated per day, daily volume of waste, daily volume of compacted waste. How much is it? Daily volume of compacted waste is, for LIG houses, it is 3,000 into 0.1 cubic meter, plus for MIG houses, there are 6,000 houses, and per household, you are getting 0.15 cubic meter of waste. For HIG houses, you are having 1,000 houses, and per house, you are generating 0.2 cubic meter. 1,000 into. I think there's some issue. Let me just open my board. I hope you have written down the values. Let me open the screen and do the calculation. Daily waste, you're getting 1,400 cubic meter. Okay. So it's like 3,000 into 0.1 plus 6,000 into 0.15 plus 1,000 into 0.2. Right? 14,000 cubic meter per day. And you want a total of 70,000. So simple unitary method. In one day, if you're getting 1,400 cubic meter, how many days you require for total of 70,000 cubic meters? Simple, straightforward after that. So I'll just write daily volume of compacted waste. That is 3,000 into 0.1 plus 6,000 into 0.15, 6,000 into 0.15 plus 1000 into 0.2. Adding all these, how much is the quantity you're getting? 1400 cubic meter? Okay. 1400 cubic meter you're getting per day. So in one day, if you're able to generate 1400 cubic meter, how many days you require to achieve the total volume of 70,000 cubic meter? Number of days will be 70,000 divided by 1400. So that will be 50 days. That's the correct answer for this last year's question, right? So that's about it. There was one more numerical. I think you can do it for your homework. I'll just mention. Okay, let me just open that question for you on the screen. Not okay, that's difficult. You can do it for your homework. I'll just write down the year for you. There's a 2 marks numerical in 2014 question paper, which you can do for your homework. Very simple, straightforward it is. Similar to the calculations we have done. It's based on the refuse chute. So there's this garbage chute refuse collection system. So the question starts this way, a refuse collection system. So look into the numericals of 2014 paper. There's a question which starts with a refuse collection system, so on. So in that also similar question, they have gave a question with respect to the waste generated and the volume required. One concept which is applied in this particular question is with respect to relation between volume, density, and weight. Can anyone tell me what is the relation between volume, weight, and density? What is the definition of density? Density is defined as density of solid waste is equal to what divided by what? Mass per unit volume. Absolutely right. It is weight of the waste, mass basically, upon unit volume. So this concept was asked in the 2014 question. You can solve that for yourselves as a part of your homework. If you know this concept of weight divided by density will give you weight divided by volume will give you density. So basically volume will be weight upon density. Accordingly, you can solve that, right? Mass per unit volume is called as density, or volume into density, that will give you the weight, right? So this relation, if you remember, you can answer. So that's about it for this topic of this will be the third question, Angel. These are the only three numericals which have been asked in GATE from this topic till now. What we solved over here, this was the second one. Third one, I have given it by home. So that's about it. So Abhishek, as far as this topic is considered, in addition to this, you can read the definitions from SWM rules. I think that should be sufficient. And if time permits, probably you can go through the URDPFI guidelines. Okay, Kartikeya, thank you for putting out the number. So you can all note it is question number 42 from 2014 question paper. So do this for your homework based on this concept of volume, density, and weight. Well, I don't think in the study material book it is included. I will need to check with that. Otherwise, if possible, from my end, I'll see if it is possible to share you a handout on it, if it is not included in the books. Chalo. Dishank, I'll share you a practice sheet. Probably that will help you for the theoretical questions, probably. For all the subjects too. For the two topics we've done today, I'll share you practice sheets which you people can solve for yourselves. KZ, you can share me the question on probably or the WhatsApp number. It's difficult to answer over here. So that's all for today. Thank you all for attending the lecture. We'll meet tomorrow. I think there will be a slight change in the schedule. The classes, whatever class plan is given, will stick to it. But tomorrow, instead of the class which is shared with you, I think it was estimation project management. Probably it will be replaced with some other topic. You'll get an update on it. So don't worry. But the class will be same time, 11 o'clock to 2:30. That's how we'll be having the classes. Chalo. Acha, Angel, okay, sure. This one, it was okay. That I think I was writing on some other PDF. So this is the continuation of it. This is the solution. You can check the recording, Angel, if you have doubt, and again you can also reach back to me as well. Chalo, thank you all for attending.
KP classes dedicated to excellence.